so great to see all of you here at our 2023 Virtual Global Conference. Welcome, bienvenidos, ahlan, wasahlan, juanin, bienvenue, willkommen, and apologize if I messed this up with my Dutch accent. I'm your MC today, Margot Garrison, co-founder and executive director of Women in Data Science Worldwide and professor emerita at Stanford University in California. Thank you for joining us at our 9th Global Wits Worldwide Conference on behalf of the whole Wits team. Our mission in Wits is to elevate and empower women in the field of data science and to create a global community to connect and provide support and year-round programming for everyone, everywhere, and at no cost. And we look forward to telling you a little bit more about our mission and Wits in a video after our opening address. But first, I've got some exciting news to share. We started Wits at Stanford 8 years ago and organically grew into this large global initiative that now reaches over 160 countries, thanks to our incredible community of ambassadors, contributors, and all of you. It's really been beyond anything we ever expected. Last year, we decided, together with and fully supported by our Stanford colleagues, that we would work to spin off Wits Worldwide as a non-profit to allow for continued growth in our community, in our programming, and our collaborations. We are so happy to tell you that we're now indeed a non-profit, taking Wits Worldwide to the next level. We remain partners with Stanford. We will continue to co-organize our annual in-person conference on Stanford campus, and Stanford colleagues will remain deeply involved with our programming and vice versa, which will provide connections for all of us back to campus. To celebrate this exciting new phase of Wits Worldwide, we've done a bit of a redesign of our look and feel. Our old Women in Data Science profile logo has gotten a fresh new look, which you may have already spotted in the opening video. It will show our bright colors and celebrate our global connectivity. We love it, and we hope you do too. We also have a brand new website full of our programming and contents at your fingertips. Check it out at witsworldwide.org. And we've been hard at work to build expanded programming. Today you will hear about our exciting 2024 Datathons, and soon we will roll out initiatives in recruiting, leadership training, research collaboratives, and outreach to secondary schools. Now back to our conference. Today we have a fabulous slate of 18 incredible women who are all leaders in their areas of expertise. We are so happy to have them with us today, to learn from them and be inspired by them. Our topics today are the critical areas of health, sustainability, language models, and leadership. The programming is interspersed by a selection of short videos that we produced especially for you. You can find the agenda for today's meeting on our new website. The moderators will put a link in the chat. We'd like to thank our sponsors and private donors who are supporting our mission so generously, both financially and through collaborations. Thank you all. We couldn't have done this without you. And before I introduce our opening speaker, one more quick announcement. If you registered for this conference, you will receive a survey to provide feedback, and you can then opt in to a giveaway. 3 of you will win a free conference pass to the 2024 in-person Wits conference at Stanford on March 8th, 2024, with 2 nights of accommodation. Keep an eye out for the survey, and I may see you in person on campus then. And now it's my pleasure to welcome our first speaker. We are really pleased that Haishan Fu is opening our conference with her address, Empowering Women to Shape the Future Through Data and Data Science. Haishan Fu is the Chief Statistician of the World Bank and the Director of the World Bank's Development Data Group. Haishan is joining us from the headquarters of the World Bank in Washington, D.C. Enjoy this opening address and have a fantastic time at our conference.
Warm greetings, everyone. I'm delighted to join you all today. I'm so heartened that the Women in Data Science Conference has brought us all together. Thank you so much, Margot, for your bold vision and inspiring leadership. My guess is that many or all of you know that Carolina Cresido Perez wrote the book Invisible Women in 2019. This brilliant book examines how the pervasive gender biases in our society leave half of the world's population invisible in so much decision-making. So I'd like to share with you 3 thoughts on the topic of the visibility of women and girls. First, we need to make sure that women and girls are visible in data science and STEM. As someone leading the development data program at the World Bank, I'm entirely focused on how to put data to work for our mission to create a world free from poverty on a livable planet. But together, we've seen the emergence of overlapping crises, from the pandemic to climate change to the reality of food insecurity, debt vulnerability, demographic pressures, and growing fragility and refugee crisis, and all of which have hurt poor countries and poor people the most, and all of which are happening as artificial intelligence is advancing so rapidly, opening a whole new realm of possibilities and risks. So the world needs talented data scientists now more than ever, and to grow the global evidence base of what works, where and why, so that we can get the right policies and actions in place to deliver help to people most in need and fast. So these are the principal challenges of our time. And women around the world must be empowered to lead on these issues. We all know that the evidence has long been clear. More than a decade ago, the World Bank's 2012 World Development Report on Gender Equality and Development made it very clear that gender equality enhances economic productivity, improves development outcomes for the next generation, and makes institutions and policies more representative. As Caroline Perez wrote, the specific importance of women in data science cannot be emphasized enough. This is also why the Women in Data Science Conference and all initiatives to drive up women's empowerment in data science in particular are so important. Second, we need to make sure that women and girls are visible in the data and statistics we collect. As we consider the crucial role of more women in data science, we must not lose sight of why this matters. We must first do more to make invisible women and girls visible in the data and statistics we collect and use. The reality is, as the title of Caroline Perez's book states, women are often invisible in official statistics we rely upon in development. The state of gender data gaps around the world is a silent crisis. It is often discussed in purpose-built forums, but is largely absent from the short list of urgent global agenda. We know that the poverty crisis is affecting women and girls in disproportionate ways, but that persistent gaps in gender data obscure needed insights and have made targeted support difficult or impossible. One exciting steps in the right direction is the work being pursued by the World Bank's Living Standards and Measurement Study team. We've launched a new surveys. It's household survey program that is focused on addressing data gaps about women and their economic well-being. For example, we now collect individual-level gender disaggregated data on land ownership, asset ownership, and rights and time use by interviewing women themselves. Thanks to this data, we now know that across several countries in Asia and Africa, women's rights and decision-making over land are considerably lower than the levels previously reported based on household-level data, according mostly to responses from male household heads. Similar insights in other countries are helping to drive reforms too. For example, in Tanzania and Ethiopia, women are half as likely as men to own a bank account. And in Cambodia, women spend 3 more hours per day on unpaid work than men. So those data are so important to guide our policy decisions and actions. And let us also remember that the value we create in filling these data gaps is extensible. We're building the standards, processes, and knowledge to close gaps for other chronically underserved and also invisible groups, from indigenous population to disabled people and SOGI issues and more. Clearly, filling gender data gaps is in every way the curb cut effect in action. Third, we must push the frontier of data science and data sources to deliver decisively and visibly for women and girls around the world and the whole society. When it comes to better data and new insights, it's clearly not enough to only improve on our traditional data collection, as we're doing with household surveys. We urgently need to explore new data sources and innovative data science applications and to see how they can push the frontier of what's possible and help us find new ways to understand and improve women's lives and livelihood and that of their families and their communities. To do so, we need to build new private and public partnerships. One example is the World Bank incubated initiative called the Development Data Partnership. The partnership enables a range of international organizations, including, for example, the IMF, regional development banks, OECDs, and more, to access data and analytics from top technology companies. For example, Google's, Meta, Mapbox, Wits, and other 20 companies. By learning through real projects, the partnership is helping us to transform proprietary data sets into sustainable and shareable insights to improve public sector services and enable our responses to crisis. Take, for example, the increasingly frequent reality of deadly heat wave around the world. Like every other climate-related disaster, women are more vulnerable when it comes to heat waves due to a combination of natural physiological reasons, their occupations, access to cooling facilities, and other social norms. Through the Development Data Partnerships Heat Wave Data Collaborative, the international organizations, private firms, and researchers are coming together to develop standard data sets, standard methodologies arising from insights from the worst heat waves around the world. As a result, we're beginning to understand better the gendered impact of extreme heat, which means that we can now take steps to mitigate these effects through targeted and timely policy interventions and investment decisions. Of course, this is only the beginning. More needs to be done, and we have a long way to go. That's why I'd like to wrap up by acknowledging that making women and girls visible in data and in data science is a priority that's too big for any one institution. It will take all of us. This is why I want to celebrate the Women in Data Science movement and endorse the 30 by 30 goal. I'm excited to join you and I want to learn from you. As an aside, I wanted to share that I'm in the process of working with my colleagues across the World Bank to professionalize data science and statistics as a formal career stream, and we need all the women we can get. Likewise, we also have a growing data science fellows program. So those of you who are graduate students, please look us up. We need you to help connect with the data science skills and solutions with the practical operational challenges we're facing in our work. So let's join forces to empower women to shape up our future together through the best data and data science possible. Again, thank you so much, Margot, for this amazing opportunity.
Women in Data Science Worldwide has been around since 2015. We started pretty small as just one conference on Stanford campus, and our aim then was to simply feature outstanding women doing outstanding work in data science. And then we grew. We grew into a global movement, connecting women and also men around the world. Our aim is to elevate and empower women. And we do this through extensive programming. We have regional events and conferences. We have Datathons every year. We've got workshops, podcasts, and also outreach programs. It's been a lot of fun.
I'm really amazed and inspired. The WiDS movement has just really taken off around the globe.
Why are we building and supporting WIDS? Because women are still significantly underrepresented. So there are a lot of voices, there are lots of brains, there are many hands that are missing in this space.
We're seeking collaborators to help us expand our national and global impact and to support several fantastic new initiatives.
We envision a future in which women are fully integrated in all areas of data science, ensuring decision-making, wealth creation, and opportunities. That's what we want to achieve in the long term.
Our immediate goal is to get to 30 by 30, 30% representation of women across all fields of data science by 2030. From beginners to leaders and decision makers, for small data, big data, and AI.
We are not at 30% yet.
So that's the WIDS mission, to change the field of data science across the globe by elevating and empowering women to reach 30 by 30.
People getting into this field, and especially women getting into this field, want to make a difference. And so they want to find a project or a problem to work on that's going to have a positive effect on somebody's life or the community in general.
And that one story, that one role model was enough to convince me that I belonged. And I think that's what WIDS is creating.
We support our mission by year-round programming and events in education, innovation, and leadership. And we make all that programming freely accessible to all WIDS community members around the world.
In education, we are establishing a WIDS Academy that will include an expansion of our current WIDS Next Gen, an initiative that focuses on middle and high school girls, along with the Upskill Academy for technical and upskilling workshops, and the development of the WIDS College Academy.
In innovation, we're really excited about starting the Innovation Collaborative. In this, we'll work with women teams around the globe to tackle critical problems that women face in healthcare, in poverty, education, and climate change.
We are also focusing on leadership to empower and elevate our community members. In addition to coaching and mentorship, we will prepare the WIDS community to recognize, find, and seize strong and fulfilling career opportunities and develop pathways to leadership.
The WIDS Uplink platform and the WIDS Leaders community will boost our impact in all aspects of leadership.
I see WIDS as making sure that women have these opportunities.
The foundational point I want to make about women is that women are creators. We must first cultivate our capacity for imagination, allowing us to create a future we haven't yet seen.
We're very happy to have Susan Donis with us today to give our first keynote address. Susan is the Chief Information Officer and Senior Vice President of Information Technology and Data Analytics at Boeing, the world's largest aerospace company. She leads all aspects of IT, information security, data, and analytics for Boeing. She joined the company in 2020 after a successful career at Qantas Airways, Procter & Gamble, and SAP. Powering today, predicting tomorrow, and innovating for the future. With a perspective from Boeing, Susan is joining us from the Boeing headquarters in Arlington, Virginia.
Hello, everyone. My name is Susan Donis. I am just absolutely thrilled to be with all of you here today to learn about data science. Specifically, I want to talk about how we use data science and IT to power today, predict tomorrow, and to innovate for the future. I am thrilled to be here with you, and hopefully you'll be able to take away some tidbits, not just for yourself today, maybe your future selves, but also to share with your colleagues. So the first question I usually get asked is, what does a Chief Information Officer do anyway? And so let me talk about what I do as a Chief Information and Data Analytics Officer, and I do believe many of my colleagues would share the same kind of responsibilities too. So essentially, there's not anything that runs in any company, I guarantee it, without IT and data analytics. So everything from your computer and plugging it in and connecting it to the internet, all the way through to how you get paid, how you order parts for your supply chain to get to your factory or to your home, and then also all the way through to how do you build things. So IT is interconnected and data analytics is used across everything we use in the company. I love what I do. I love what I do working for Boeing. I'm going to talk a little bit about what we do for Boeing, but we build some pretty inspiring products that help connect us to people across the globe to protect peace and freedom, and also to explore our world and beyond as well. So let's talk a little bit about what Boeing does. I hopefully know that you know a bit about the brand, but I think many people don't appreciate the breadth of the products that we support. And it's really important when I talk about the context of data science. The context that you work in is really important. And one of the things I would encourage you to always do is to make sure that you're understanding the context of your business, because context is everything. It is not just the execution, it is how we are thinking about embedding the execution in your environment. So at Boeing, we basically have 3 business units. The first one is a commercial airplane. Hopefully many of you have experienced these products before. It's products that fly you across to visit your loved ones, from the beloved 787, the 737, and even the 767 that delivers all of your home order deliveries as a freighter to your home and to your business. The other business unit that many of you might have heard about is defense, space, and security. So defense is everything from F-18 fighters to things like Chinooks, Apache helicopters, really amazing aircraft, all the way through things like the Starliner and SLS. SLS is something that we will use to power us to get to the moon and to Mars and to beyond. It is the most powerful rocket that has ever been built. So pretty complex environment. And the last one is services. So this helps us modify our aircraft, keep them safe, keep them up and running, but importantly, deliver parts to all of them, and lastly, to help run them. So a lot of our pilots and the crew use the tools to help understand airports and the safety in the air as well. So hopefully you've experienced some of our Boeing products, and if not, I hope you will have the delight and pleasure to experience them in the future. Perhaps we have a future astronaut in our midst as well here, and you can experience some of the defense, space, and security products. So under that context, I want to talk a little bit about what we do and why IT and data analytics is so important. I alluded to it at the very beginning. Nothing runs in this company without the IT and the data analytics. It is a key strategy for our future, because even though we will obviously continue R&D around metals and how we put our products together, the digital component of how we put our products together is critically important. The reason for that is these are very complex products with very low levels of error permitted. So it is beyond 6 sigma, it's 10 to the minus 9, which means that your error rate needs to be minimal. So when you can build things digitally many times over before you actually physically have to, it eliminates not just waste, but ongoing build and maintenance. Because often what happens is you design a very complex product and it is near to impossible to build it to specification. In fact, in some cases, we use the 3D models and 3D printing to build our products, because there is no machine or hands that can actually build a product in that manner. So hopefully that gives you a good example of how we use it. Also, a lot of our products are flown using digital enablement. So what that means is when you have an autonomous aircraft, it is flown through AI and machine learning. So this is all powered by data and analytics as well. So I hope you can appreciate how digital is firmly not just ensconced in everything we do, but how we think about our future. And I would say that most companies, when you hear about them speak, they're talking about being technology companies, data companies, and with new technologies, or rather they're not new, but technologies that are getting adapted and adopted, like generative AI. Generative AI has actually been around for a while. You'll see that companies are really looking at these technologies to help differentiate them. So let me talk a little bit about some of the examples of how we use that within Boeing. Hopefully you'll be thinking about the examples of how you use that within your own companies, and what you're learning about potentially in university as well. And hopefully you'll be inspired to how that can be either different, or how you can use that to create strategic advantage, or to help grow, as I said, your customer delight across any business that you are supporting. So the first thing is that data powers everything. And I've been working in IT and data analytics for well over 20 years now. And I have to say, some of the things that I learned early in my career still apply now, which is data and the quality of the data is important. If you have garbage data, no matter how many analytics or technology you put on top of it, it is not going to help, because garbage in still equals garbage out. So that's why having a really great foundation around not just the quality of your data, but where your data is and how you can combine it is important. And I just want to illustrate that through an example. We have created a tool, and you can go online and use it. It's called the Cascade Climate Impact Tool. And essentially what it allows anybody to do, yourself, but it allows policymakers or CEOs that purchase aircraft to model what would their climate impact be to net zero emissions if they looked at different components, such as when they're going to renew their fleet, renewable energy sources, operational efficiency, advanced technology. So all of these, using different levers, you can model what it would look like if you were using a hydrogen or an electric propulsion, combined with all three of these different criteria. So what that allows you to do is to combine data internally that we have available at Boeing, but also externally, which is available across various industries. And that is really the power of data, is how you combine it to give you some insight, which is the last piece of work. It's not just the data, it's the insight. What are you going to do with the data is really critically important, because otherwise we're serving up a lot of data that either isn't actionable or that there's nobody there to action it. So we've built this tool in partnership with IATA, which is the Airline Association, NASA, and the University of Cambridge. So it's a really nice example of how industry will work across competitors, even universities and not-for-profit organization, to improve the outcome of our net zero emissions. And I'm fairly sure you can think of various examples in your industry of how putting the data together and collaborating will help you lead to better insights and outcomes. Another example I want to talk about is something you might have heard about, which is called the digital twin. Some of the data is also referred to as the Internet of Things. So let's talk a little bit about what that is and what it means. So basically it means, how do you create something in the virtual world that is the same as what it would be in the physical world. So what you have to do that is you actually have to have something that in the industry we would refer to as the digital thread. I like to call it the digital fabric because a thread is very thin and has one single line, whereas a fabric is all these threads woven together. So essentially what it means is how do you pass information from various systems? Because when you look at a digital thread, for example, factory automation, you want to be able to develop your airplane or your helicopter or your Starliner various times before you start to build it. Because in some of these cases, for example, the Starliner, we don't create hundreds of copies. We create a very few copies. So it means that each one needs to be literally perfect. So remember, 10 to the -9, not even a hair, human hair can fit into some of the wedges where they're not supposed to fit into. So in order to do that, you have various systems because the amount of data that we use to integrate is terabytes of data. Terabytes of data is a lot of data. It means, I think once I looked at it, it was like watching movies continuously for a year. So that's the amount of data that is going through some of our products in our aircraft. So in order to do that, you have to link all the systems together with all of the data. So in order to do that, what we do is we have all sorts of digital tools that allow them to design the aircraft, but also to understand how would you build it. And you go through various iterations of this till you come up with something that can be built in the way that is designed. And you can actually test it millions of times before you fly it. Because when you physically test things, there's only so many different things you can do. Throwing chickens into the air and flying through them. You can do this hundreds of times virtually and before you have to do it physically, and you can test these things too. We even test some of these, the way the wind works and moves. Before, the way we used to do it is you would hang little strings from the aircraft and look at it through a wind tunnel. Actually, now we can digitally model, actually using AI and machine learning, how those little strings would flow into the air. So we actually don't need to do that as many times. Another great example is airplane wiring. Hopefully you've seen wiring in different mechanical devices in your life. But when you look at some of these devices in your computer, you'll see that some of them are very tiny. When you look at them in an aircraft, some of them are tiny and some of them are huge. And the complexity of the number of wires that have to go through, but also how you have to ground the wires and how they need to be separated and how you test them is actually very complicated. So if you've ever had to build something in your house, like an IKEA bookshelf, for example, you'll understand that it's complicated to look at a 2D drawing and then try to make it in a 3D output. And so what we use is virtual reality lenses. There's lots of different companies that produce them. And what it allows is the mechanic to see what the drawing should look like and where it should be, and if it is misaligned with what it looks like. So imagine, you putting together your IKEA bookshelf and seeing that you've actually done something incorrectly as you do it versus when you've put it all together and you need to take it all apart. So that's the kind of things that we use the digital twin for. And then the last example I want to talk about, as I said previously too, is you can't get through any article or any news feed without hearing something about generative AI. And I just want to take a step back, which is I talked a little bit about, having the data, curating the data is really important, but also asking the right questions. And if you've experimented with generative AI, what you will know is actually the better you are at asking the right questions, the better outcome you will get, which is the reason why oftentimes in technologies like generative AI that can create new insights through via complex data that's coming into it and simplifying it, you actually are positively impacted by having somebody who knows a little bit more about it. Because when you know something about something, you can ask better questions, which goes back to my comment at the beginning, which is content and understanding your content and your context is really important, because the more you understand it, the more nuanced you can be with the questions that you're asking. We're using it. A lot of companies are using it for everything from coding to also just even helping us do research. One of the things that we've been very focused on, and I would encourage you all to think about this too, is you've got to put the human in the middle of all of this. So it's the human that still has the right judgment. There's something in generative AI called hallucinations. You've got to make sure that you've got somebody looking through this that has the right judgment, has asked the right questions, but also can filter through it to make sure that the output we're getting is accurate. So just in terms of wrapping up, I just want to talk about a little bit about my leadership lessons. Hopefully it'll resonate with many of you. I've had a career, as I said, over 20 years in technology. And I have to say the most important thing I can tell you about technology is it's about the human, sometimes more than it is about the technology. Managing change and getting people to adopt and adapt to new work processes, because in general, when you're implementing a new technology, you are changing the way people work, is really important. So understanding the psychology about how people want to adopt change is really important. And again, it goes back to understanding the processes and how everybody works through the processes versus just understanding how the machine would do it. I'm telling you, that's where projects fail, is because we all think we're machines and we'll follow instructions perfectly. And there's a lot of science behind what motivates people to change and what motivates people to do things differently. So I would really encourage you to look at user-centric design. One of my biggest learnings is, in my case, it's walk the factory floor. If you're closer to customers, make sure that you're observing how customers interact with your products and what they do, because that is a big source of not just innovation, but a big source to understand how people will adopt new technologies. They won't just do it because you say it's better. They'll do it because it provides a significant benefit for them. I find, people don't want to change if it's 10% better. They want to change when it's 50% better. The other thing I want to talk about is focusing on leadership is about being inspired, but also being able to execute, because people will follow you when they see that you've got an inspiring mission and when you engage them in it. It's not necessarily about who reports to who anymore. And so I would just encourage you again to make sure that you are being empathetic with your users, because you will find that you will get a lot more people along in your journey with you when you're starting it with the human in the center of it all. So with that, I will end here. I will hope that you took something away from this. I will hope you will think about your future and how you enable technology or use technology and data analytics to improve the outcomes of your company, of our planet, of the employees that you work with. But you also think about this in terms of diversity and inclusion, as well as how can you make everybody have their best day in the office or outside of the office by using these tools. I'm also incredibly proud that Boeing offers wonderful internship programs, as many companies do. And if you're in university, or you're lucky enough to be in university and at the start of your career, I would definitely encourage you to look at different internship programs as well, so you can experience some of these things firsthand. So thank you, everyone.
Thanks so much, Susan, for that wonderful keynote. We have so many incredible women in data science in our community from all around the world, and we'd like to introduce you to some. So please enjoy the next 5 minutes with a video featuring stories from Philomena from Nairobi, Kenya, Becky from Brisbane, Australia, and Amanda from Colorado in the United States.
My name is Philomena. I'm a data scientist here in Kenya. I remember when I was starting out my career, I used to spend most of my time behind the laptop, and it got to a point where I felt like I was a bit overwhelmed. It was very monotonous, and I felt like I was not thriving. Work-life balance means being able to not only flourish in one area of your life. The different areas of your life would be your career and also your personal life. And so it's just about finding the balance between the two. One thing that I love doing is dancing. It started just as a hobby, something I would do with my friends, but now it's become something that's more routine and something that I really, really enjoy doing. I grew up in Nairobi, and this is me with my mom on a Saturday morning at the farm. Growing up, my mom really had a strong interest in farming. She always said that it's something that she wanted to go into. And so what started out as just me helping her out in the farm quickly became something that I was very invested in, what we're planting, what we're growing. So one thing that I've actually learned about myself that I did not know about myself before is the fact that I'm an extrovert. Putting myself out there in the various activities has really enabled me to rediscover myself. Things that have enabled me to even get over some of the fears that may have propped up while growing up. This has even helped me to rediscover some of the strength I never really knew existed before.
My name's Becky Cook. I am a Ngunnawal Aboriginal woman. So the Ngunnawal people are part of the Quandamooka community, which is from Stradbroke and Moreton Islands, just off the east coast of Brisbane, Australia. While my primary focus is as the centre manager and coordinating things within the office and the centre, I also have the opportunity to work on research projects, and I'm currently working with community on a project surrounding enhancing data literacy in the Indigenous community. The biggest impact is the potential to improve the well-being and socioeconomic outcomes for Aboriginal and Torres Strait Islander peoples through the best practice use of data. The NAIDOC Week stands for Aboriginal and Torres Strait Islander Day Observance Committee. And this has developed into a week-long celebration and recognition of Aboriginal and Torres Strait Islander culture each July in Australia. Part of my role, I spent the day engaging with members of the community, having conversations about data and whether they would like to enhance their use of data and how they were using data in their everyday lives. The outcome of participating in this day was that we were able to consult with the community surrounding a proposed project that we had on enhancing data literacy. This meant that our project was informed by the community at those early stages of the research design. We were able to hear what the community wanted and also incorporate this into our work. It's also part of the ethics process. So my advice for women data scientists would be that you do belong here. I myself am not a traditional data scientist, meaning I'm not a statistician or a computer scientist, but I do feel I'm contributing in this area of data. So if you're passionate about what you're doing, you're going to be successful.
My name is Amanda Melberg. When I joined Dataiku, and I already saw the Empower group. Empower serves as a safe space for Dataikers to discuss the challenges that women face in business and beyond, and provides advocates to allow us to grow a sense of belonging for all women so that people can have the freedom to choose how they want to show up at Dataiku. What's been most exciting is we've really become like an actionable women's group. So in October 2021, in one of the Empowered group meetings, I introduced what the WiDS organization was, hoping to recruit some other women to help in organizing the event the following year. Dataiku had already heard about WiDS. There's so many folks that are women in data science, and so I thought it was just a great pairing. This year, we have over 25 WiDS ambassadors across EMEA, America, and APJ. And so that was really exciting because we had the Empower group to kind of talk about things, but then we had the WiDS regional events to kind of practice what we preach in a way, and bring a lot of the cool stuff that we were talking about internally to other members of the community. My advice would be to lean into these communities that exist, such as the WiDS community, or bring the WIDS community to your company and kind of jumpstart that initiative and create that community that you potentially seek, because I think it provides the mentorship and sponsorship that we all need to truly thrive in our careers.
We hope you enjoyed hearing from Philomena, Becky, and Amanda. We are now starting our first block of the day, 3 10-minute talks on language models and ChatGPT, followed by a conversation with the 3 speakers. In the next 50 minutes, you will hear from Kathleen Siminu from Kenya, Karen Howe from Hong Kong, and we start with Chelsea Finn from California. Chelsea is an assistant professor in computer science and electrical engineering at Stanford University. Her research interests lie in the capability of robots and other agents to develop broadly intelligent behavior through learning and interaction. Enjoy her talk, which is titled, Language Models Make Stuff Up. What should we do about it?
Hi everyone, my name is Chelsea Finn, and I'll be talking about some of our research on how language models make stuff up and what we should do about that. So as motivation, machine learning has been deployed quite widely, especially in scenarios where getting the right answer isn't critical. For example, in recommender systems where you just need to recommend things that are going to be helpful and useful and interesting to users rather than the exact best thing that should be recommended. Machine learning is also quite useful and has been deployed widely in scenarios where getting the most common use cases right is pretty useful, such as in Google Translate. And it's also useful in cases where the goal is really to make an expert faster, such as in code generation in Codex. And arguably, machine learning has been really successful in all of these scenarios. But at the same time, we've also seen examples where machine learning models have fairly important and critical failures. For example, if you tell a former version of Bing Chat that today is in 2023, it will try to convince you that today is actually 2022. It also somewhat notoriously tried to convince a New York Times reporter that the New York Times reporter was married but not happy in his marriage. And I think that these sorts of kind of failure modes that we see come up can happen in a few different circumstances. The first is when their inputs deviate from the training data, essentially when there's a distributional shift between training and testing. The second is when the model underfits to the training objective. And the last scenario is if it is actually fitting its training objective well, but it's not doing so in a way that is actually aligned with the kind of behavior that we want. Essentially when it isn't penalized enough for making up answers or for making mistakes. So this kind of observation that machine learning models make stuff up, this is okay in some scenarios. In some scenarios, we actually want these kinds of models to make stuff up, such as when we want them to generate a dragon fruit wearing a karate belt in the snow, or generating an image of teddy bears swimming an Olympic swimming event. But in other scenarios, the fact that models are unreliable when they're deployed can actually be pretty problematic when those models are interacting with real people. For example, when news sources are actually using these systems to write articles, when mental health companies are trying to actually use this to talk to people with mental health conditions. And it's also really a deal breaker for safety critical scenarios, such as in medical imaging settings. So what I'd like to talk about today is what we should do about this, and specifically some paths towards technical solutions. I don't know exactly what the answer is here, but I think that there are some things that we can do from the technical standpoint to try to address this problem. The first is to build tools for people to try to be able to detect model-generated content. The second is to help models better know what they don't know. And the last is to actually try to improve the model's predictions in the first place. And as we go down this list, we get more powerful tools, but the kind of tools that we're trying to build here get harder and harder. Now, I don't have time to talk about all of this, and so I'm going to focus on the first two. And I'll first by just briefly mentioning some of our work on trying to detect model-generated content. The idea here, or the initial idea here to actually solve this problem, would be to try to train another language model specifically to be able to detect if text was written by a model or by a person. And large language models can actually learn very powerful classifiers that can detect machine-generated content. But to do this, you actually would need to spend a lot of time gathering data from the model and data from humans, training the detector. And even when you do that, the detector will probably overfit to specific domains, styles, and languages. And so we're actually going to take a different approach, which is actually to use the source language model itself to try to detect its own generations, and to do so in a zero-shot manner without actually using any training data to try to train it for detection. And our hypothesis is that samples and text generated by the model are in a local optimum of the model's log probability function. Essentially, another way of saying that is if we rephrase the text generated by the model, the likelihood that the model assigns to that text will probably drop a little bit. And so visually, we think it looks something like this, where model-generated content is going to be kind of near the peak, for example, on the left-hand side, whereas human-generated content is not going to be at this local optimum. It's going to be somewhere else on this kind of curve of model probabilities. And under this hypothesis, we can actually use this to detect samples. We can use another language model to sample small perturbations of a bit of text and check if those perturbations actually cause the text to have a lower probability under our model. And if they do, that means that it's probably generated by the model. And if not, that means it's probably generated by a person. And we find that with this sort of approach to detection, we can actually get a pretty good detector. And in comparison to classifiers shown in white and gray here, we're able to get a detector in yellow that matches those classifiers on 2 different English data sets on the top. And when you actually look at harder, more out of distribution data sets like German in the bottom right or medical text in the bottom left, we're able to far surpass these supervised classifiers, which really struggle on this more technical text and on text in other languages. So the summary here is that first, of course, model-generated text really deserves more scrutiny than human authors. And DetectGPT uses a language model itself to detect its own outputs. But of course, it also has some limitations. It's going to be sensitive to rephrasings. It's also pretty computationally expensive. And even though we have some signs that it's pretty good, I wouldn't use this detector in prime time to actually make decisions that affect human livelihood. And if you actually want to try out the detector yourself, we actually have a demo online at this URL, and you can check it out. So now, beyond trying to detect model-generated content, the next thing that we try to look at is whether models can actually understand what they don't know so that they can refrain from making predictions in the first place. And this is actually a really challenging problem. Essentially, we want to encourage the model to be unconfident when it sees inputs that are out of the training distribution, that are beyond what it was trained on. And the reason why this is really challenging is that there's really an infinite number of ways that data can change between training and testing, and it's hard to anticipate the full range of possible test inputs. And so we're going to not try to solve this challenge itself. We're actually going to try to sidestep this challenge and actually use representative examples of out-of-distribution test inputs. We'll call this our uncertainty data. And the good news is that we only need unlabeled representative examples of these test inputs. We don't need to know what the correct response or what the correct label for these inputs is. And then what we'll do is we'll fine-tune our model both to minimize the training objective, but also to minimize confidence on this uncertainty data. And so essentially, we will be taking the typical training objective and encouraging the model to make accurate predictions on those training examples. And then for this uncertainty data, which could be kind of unlabeled test examples, or it could be mislabeled validation examples, we're going to encourage the model to actually have a uniform distribution over possible outputs for those inputs. And once we do this, we ran a number of experiments. I don't have time to go in depth, but on selective classification problems, we found that this was consistently the best method on 4 different image data sets spanning satellite images, medical images, and natural images. And it matches or significantly outperforms ensembles with 5 times less compute. So it's a pretty compelling method. And so overall here, first, kind of one takeaway that I'd like to instill is that we can't really expect these kinds of deep neural network models to make reasonable predictions on arbitrary out-of-distribution inputs without having trained on them. And our approach of kind of data-driven confidence minimization actually tries to explicitly train for low confidence on new inputs. And I didn't talk about this, but we actually can show some nice theoretical guarantees under some fairly mild assumptions, as well as some competitive empirical performance. Now, looking forward, I also like to mention that perhaps we should actually rethink the whole way that we train language models and neural networks. I talked about a couple of different tools, but kind of this typical approach of just training models to predict next words actually differs a lot from how humans are trained. For example, when humans are kind of trained in the context of the world that we live in, and they're penalized for making mistakes, for making things up, for being dishonest, and so forth. And maybe if we were able to train machine learning models situated in the world where making mistakes has consequences, then maybe they would actually be more human-like and actually care a lot more about things like factuality and honesty. And of course, lastly, maybe we should also figure out how to get humans not to make stuff up, because humans also will tend to make stuff up in a variety of scenarios. Great, that's it, and thanks for your time.
Thanks so much, Chelsea. Our next speaker in this block is Kathleen Semenyu, who's an AI researcher focused on natural language processing for African languages. She's based in Kenya and works at the Mozilla Foundation as a machine learning fellow focused on Kiswahili speech recognition. She will discuss community building activities to support this exciting program.
Hi there, my name is Kathleen Semenyu. I'm a machine learning fellow at Mozilla Foundation working on a project known as Common Voice. My research work on this project is focused on building speech recognition tools and datasets for Kiswahili. And broadly, my research interests lie in building language tools for low-resource African languages. My topic for today is community building for Kiswahili automatic speech recognition. And in this work, I'll be taking an exploratory analysis of the dataset for Kiswahili that we have on Common Voice and tying this in with the community engagement activities that we have undertaken in the efforts to build this dataset. So what is Common Voice? Common Voice is a platform to build speech recognition datasets. It's open and datasets are generally crowdsourced. We encourage communities, initiatives, and organizations to self-organize and build language datasets for whether it's the languages they speak, those that the communities around them speak, or those that they care about. And we think this work is important because historically, speech recognition advancements have been led by private companies whose datasets and tools are proprietary and therefore not open to the public for evaluation or interpretation. We think that this limits the advancements in the field and therefore hope that the existence of this platform means that more communities can self-organize and that speech recognition technology can be further democratized. In terms of features, there's 4 main features that the platform provides, which I'm going to highlight. The first is the ability to add or create sentences for the respective language on the platform. And the second is the ability to validate these sentences. Third is the ability to record one's voice as they speak. Typically, you'll come to the platform, be served with one sentence from the underlying text or the already existing text for the language, and then you'd read out this sentence and record yourself while doing it. And finally is the ability to validate already existing audios on the platform. There are many language datasets which are hosted on the Common Voice platform. My work and the focus of this presentation is going to be in Kiswahili. This is work that has been ongoing for the past 2 years. So we began in June of 2021, and we had certain goals set out, one of them being to get to between 1,000 and 2,000 hours of data. The rationale for this number being that this would certainly be enough data to build good speech recognition systems with. This is work that is funded by GIZ, which is the German Development Agency, by the Bill and Melinda Gates Foundation, and by the UK Development Corporation. So with this first chart, I show that we have a 1-to-7 ratio of sentences to clips. Again, you remember that first sentences have to be uploaded onto the platform, and then individuals come and record themselves reading out these sentences. So we definitely have way more clips than sentences, or significantly less sentences. And there's several reasons why this is, there's several potential reasons for this. One being that because the entirety of the dataset has to be open, the underlying sentences also have to be free of IP or copyrights. And it has been significantly difficult to access such texts. So we've had to be creative about creating platforms and collaborating with writers or students of Kiswahili literature and language to create such text. It potentially also speaks to a preference of our community to read out or record their voices as opposed to creating texts. But then in terms of implications for developers, we'd suggest that they be critical about how they use the data, because the 1-to-7 ratio can imply a lot of repetition. So it's worth considering some data augmentation to ensure that the data is being utilized well. Next chart is displaying our validation rates. We have approximately 50% validation of the data set. So this is the two bars in the middle, the validated and the invalidated. This is an important metric to track because it speaks to the usability of the data set. It's the assurance that we're able to give developers or researchers who come and use the data set. Out of the box, the way the Common Voice platform creates experimental splits is by only using the validated data. So the validation rate also speaks to the usability of the data set. And in our case, essentially 50% of the work that we have done cannot be used yet. So we are working on kicking up our validation efforts. Next, I'll speak to the gender distribution of contributors. First, you'll note that 50% of our contributors did not share with us their personal information. This is actually a feature of the platform. It is optional to create a profile, and it is optional to provide us with your personal details. We do this out of the box because we would like individuals who have any reservations about sharing this information with us to still contribute their data. Another reason for this 50% margin is possibly because we collect a lot of data at events where a booth is set up. And people will typically be walking through an exhibition area, and we have the opportunity to speak to them about Common Voice and perhaps have them contribute 5 clips and encourage them to go home and continue the work if this is a mission that they are interested in. Then additionally, for the contributors that did give us their information, we have an almost 50-50 split between the men and the women. And this is something that we're very proud of because we've been very intentional about it since the beginning. So from speech recognition literature, we learned that it is more likely to build systems that have better performance for men than for women. And this is due to imbalances in the data set. So we have been very intentional about including women at every stage of the process. Next, I'll speak to the age distribution of contributors. Again, there's the approximately 50% who did not share their information with us. And for those that did, you'll see that an overwhelming majority lies in their 20s. So there are many reasons, or many potential reasons for this. From speech recognition literature, again, we learned that such systems and therefore such data sets are more likely to perform better for younger people as a result of the constitution of the data set. It may also be that in our work in particular, we did a lot of partnerships with universities and tech hubs, and generally the age groups of individuals at these institutions is on the younger side. So one of the implications of this as a constitution of our data set is just the fact that any downstream applications are likely to be biased and have better performance on younger populations. And so the recommendation for any researchers or developers using this data is to ensure and be intentional about evaluating their models and their work on a better distributed test set, and potentially do some fine-tuning to make up for the difference, if any. Finally, I would like to encourage you all, if you're interested in speech recognition, to check out and consider the Common Voice platform for your work. If the language does not already exist, there's loads of resources and links to documentation on this slide that can walk you through the process of beginning to localize the site, collect sentences, and then move on to the creation of the data set. And I hope that this slide deck will be shared for you to have access to all of this. That brings me to the end. Thank you very much, and enjoy the rest of your WIDS.
Asante, Kathleen. Our final speaker in this block is Karen Howe. Till recently, she was a foreign correspondent covering China tech for the Wall Street Journal. Karen is an award-winning journalist covering the impacts of artificial intelligence on society. She joins us from Hong Kong for her talk, How the Other Half Lives, the Hidden Labor Behind ChatGPT. Directly after her talk, I have the pleasure of sitting down with all three speakers in this block, Chelsea, Kathleen, and Karen, for a deeper dive.
Hi, everyone. Thank you so much for being here today. And thank you so much to Wits for having me. As Margot mentioned, I'm a journalist and I've been reporting on AI for 5 years now. And I've profiled people creating the technology, people fighting to change the technology. I've also traveled around the world to profile people affected by the technology. So I wanted to share with you one of the most recent stories I did about a group of workers in Kenya who found themselves doing work for a company that they didn't know and for a product that they didn't understand, and how that ultimately left them with anxiety and depression still more than a year later. And I share this story because when we talk about building beneficial AI for everyone, as OpenAI often likes to say, it's really the experiences of the people at the margins that give us the most accurate measure of whether or not we're achieving that goal. So first, why were there people working on OpenAI's products in Kenya? This is a phenomenon that's much bigger than ChatGPT and much bigger than the AI industry. All digital technologies, internet technologies, have always needed what Mary Gray and Siddharth Suri, two Microsoft researchers, call ghost work. And they define ghost work as the human labor powering many mobile phone apps, websites, AI systems that can be hard to see and is often, in fact, intentionally hidden. And one of the ways that it's hidden is it's outsourced to lower income countries. And ghost work, the demand for this has really exploded with the AI industry because of the need for data annotation. All the data that goes into training AI models needs to be cleaned, it needs to be processed, and that work has to ultimately be done by humans. And globally, that work ends up being concentrated in countries that essentially share a few characteristics. They have high education levels, good internet infrastructure, but high unemployment rates. And Kenya checks off a lot of all of these boxes. It also, on top of that, has an English-speaking population because of its history of British colonization. And this becomes important because it is now a major hub for data annotation for language AI technologies. So in 2021, when OpenAI began looking for their data annotation partner, it was sort of natural that it ended up finding its way to Kenya through its outsourcing firm called Sama. So OpenAI specifically went looking for workers to build its content moderation endpoint. And on its website, it actually has a pretty detailed breakdown of what this endpoint does. So specifically, it is used to check whether content complies with OpenAI's usage policies. And then once the content is identified, developers can decide whether they want to take an action against it, such as filtering it. So essentially, it is a safety filter that is attached onto models, and OpenAI itself uses it for ChatGPT, GPT-4, but it provides it as a service for other generative AI developers as well to check the systems, to be the final check on their generative AI systems, to see whether or not an output should be presented to the user. And on this site, OpenAI also details exactly the categories that it looks for, things like hate speech, self-harm, sexual content, including sexual content with minors, or extremely graphic violence. And this list is precisely the kind of content that OpenAI ultimately asked workers in Kenya to review. So the workers in Kenya were being given detailed text passages, sometimes up to 5 or 6 paragraphs long, that were talking about things like sex with minors or extremely graphic violence. And they had to read all of these passages, assign them a severity level, and then deliver that back to OpenAI. And for this work, they were ultimately paid between around $1.50 and $3.75 an hour. So how did this affect the workers? The first story that actually broke this was in Time magazine in January, where it talked about how OpenAI had outsourced this labor to Kenyan workers and how it left them with a lot of PTSD. So I ended up going to Kenya in May to meet them, to hear their stories. And I wanted to just play for you, in their own words, in his own words, Alex Cairo's experience, who is a 28-year-old worker on the violence content team.
When you would go home at night, like what would you think about after 8 hours of reading all of that stuff?
Oh, my mental state was very bad. I had nightmares. I feared people. Maybe I see too many people coming, I see violence. If I see someone holding a fork or a razor blade, I see people cutting himself or something like that. At night, I will dream, I will have nightmares. Even I'll tell my brother, okay, just come here, sit with me like for 5 hours before I go to sleep, because I need someone to talk to before I go to sleep, because if I go to sleep, I'll start screaming or something like that. So many things are going a lot in my mind, yeah.
I also met another worker, Mofat Okinye, who was on the sexual content team, and Mofat told me that he read things like parents raping their children, children having sex with animals, with each other. And Mofat also made clear, on top of all of the things that Alex experienced, that this work didn't just affect him as an individual, it also can affect a community. And in his case, it affected his family. Because he was on the sexual content team and he was spending so much time reading this stuff, he became very emotionally distant from his wife and his stepchild. Every time he saw his stepchild, he thought about these passages that he'd read, and he started having really socially anxious behaviors. And his personality changed so much that ultimately his wife ended up leaving him and taking her daughter with her. And so the other thing that when I was in Kenya that I went to do, I visited other workers that also are part of the data annotation industry, but didn't necessarily work on the OpenAI project. And what I learned, and kind of based off of other reporting that I've done in this area as well, is for OpenAI's workers, they were already dealing with extremely traumatic content, and that in and of itself was harmful to them. But other parts of the data annotation industry that don't deal with that, the content does not necessarily have to be traumatic for the workers to also experience a lot of really difficult challenges and a level of essentially labor exploitation in participating in this industry. This is a photo of a neighborhood that I visited to go see a worker that was part of the data annotation industry that didn't work for OpenAI. And this is a photo of her with her family. So this is Winnie in the fedora hat with her partner Millicent and their 3 kids. And what Winnie described to me was these jobs, they're not 9-to-5 jobs. They're not stable jobs. She spent her days tethered to a computer waiting for work to come because she never knew when it would arrive. And when it did arrive, she would work for 22 hours straight, not sleeping, because she was worried that if she went to bed, the work would disappear. She would lose out on the opportunity. But then when the work didn't arrive, it could wait. It could take months for new work to come. But because she didn't know when it was coming, she would wake up every day, sit next to her computer, and just sit there and wait for the work to come. So ultimately, even though she was getting a job, she was getting paid and getting economic opportunity that she might not have accessed. In the end, she wasn't actually necessarily net gaining in income, because there were so many long stretches in which she had no income, but she never went to seek other jobs because she was worried about being home and waiting for these economic opportunities to arrive. So I guess the good news is that there is actually, in fact, a huge opportunity here. Like the way that these jobs are being implemented right now are not good jobs. They are not well-paid jobs. They're not stable jobs, but they could be, and there's no reason why they shouldn't be. And there's an organization called Fair Work that's run by the Oxford Internet Institute that studies lots of gig work across many industries and has a set of principles that basically organizations could follow to provide actual meaningful work and, in fact, careers around this kind of work. Some of the things that they say are we should let workers know what work they're actually even doing and who their clients are. Like the workers working for Sama didn't even know that they were working for OpenAI. They should also be able to have a manager. Like Winnie didn't even have a manager to contest working conditions with. She didn't even know who she was dealing with day to day. So as the Sama workers told me, they said, treat us like professionals. We have opinions, give us a seat at the table. And not only will that make their working conditions better, it'll also make the technology development better because there will be more diverse opinions in the development of it. And remarkably, we are seeing Kenya workers starting to organize demand rights and ask for legislation in this area. But there needs to be international coordination. There needs to be regulation, because what if Kenya implements rules and other countries don't? Data annotation firms can easily move from one to the other. So we really should be taking a cue from the Kenya workers and helping them build more momentum around the movement that they've already sparked within their own country. And if we want to build AI that benefits everyone, we should ultimately start with the development of the technology.
Well, Kathleen and Karen and Chelsea, it's just wonderful to have you here. And I wish that we could have this conversation at a real coffee table, chatting about your talks and taking a little bit of a deeper dive, but wonderful to have you in the studio. And it's really quite interesting to think about what time zones you're all in. I know that Karen is coming in from Hong Kong and Kathleen is coming in from Kenya. Chelsea and I are on the West Coast here of the United States, but we're spanning the globe with this panel. I just wanted to ask as very first question, because a lot of people always are interested in, you talked about some fascinating research that you all do in the area of natural language processing. How did you get to this stage? Now, what happened in your career that made you work on these problems now? Is there a moment in time when you say, hey, this is the direction I want to go? Or did you happen on those topics? I'm sure that the audience would love to hear a little bit more about your journey to this point. Karen, you want to start?
Yeah, sure. I guess I didn't necessarily pick natural language processing as a focus. Because I cover AI, I kind of just go where the field goes, and because the field has really concentrated on large language models over the years, it became an increasingly important part of my reporting, and a very fascinating one. I'm really glad that I get to cover this area. But it encapsulates the thing that I love about recovering language AI is it encapsulates so many different themes within AI and society, because language is so inherent to society and to the way that people relate to one another and to different cultures and countries. So you kind of get all of the things that you would want to explore about AI and society in NLP by itself.
What about you, Kathleen?
So there's no one point that I can single out and say this is the moment in which I picked it. It's been more of a series of decisions that found me or led to me being here. So my background is in math and computer science, and with this, I started my career working as a data scientist. I just so happened to be working at a company in the telecommunications space. And so our products were stuff like voice, SMS, airtime. And one year I was tasked to build a text message filtering tool, but it needed to be filtering messages that are spoken in local languages spoken in Kenya. And this is essentially how I uncovered the fact that there's actually so much you can do in terms of language tools if the languages you're working in are English or other dominant Western languages. And so none of these tools were of use to me in that context, and we ended up hacking something very rudimentary. But this is what opened my eyes to the fact that there's a huge gap in terms of resources available for African languages. And ever since, I've been working in this space.
And Chelsea?
For me, I've always really been fascinated by the problem of AI since I was an undergrad, both in terms of this notion of trying to build intelligence in machines being a really fascinating problem, and also the potential impact that AI systems can have on society in a positive way. When I started my PhD, I actually explicitly decided I didn't want to work on language and I wanted to work on other things, and ended up working a lot on robotics. But when I joined Stanford, and I still do a lot of work in robotics, but when I joined Stanford, I've had one student who was really excited about working with me and the technical ideas that I had developed, but also wanted to try to take them in the natural language direction, and found a co-advisor in NLP that was willing to advise him as well. And he kind of dragged me into the field a little bit, and it's been a lot of fun to work with language models and start to study some of the problems in the field.
And certainly natural language processing and large language models have gotten in the news a lot more lately after the splash of ChatGPT. And I was actually really quite surprised at the incredible attention paid to it when it first came out. Having been in the field for a while and knowing what has been cooking, it's surprising that this one release, to me at least, that this one release really hit such a nerve with many people. What was, in your opinion, so special about this ChatGPT release? I'll go to you, Chelsea, to see what you think.
Yeah, so to me, it's also quite kind of crazy, especially having worked in AI for a long time, that now so many people know about what the latest and greatest in the field is, like where the technical bleeding edge is. I think that one thing that was different about ChatGPT compared to other AI research is that it's just so accessible. There was this interface online that anyone could interact with, and that accessibility made it such that it was really easy for really anyone who could access a web browser to try it out and see and look at it. And a lot of AI research, might need a GPU, or you might need to know how to code in order to start to interact with these technologies.
Yeah, I totally agree with that. I think from the perspective of watching, like before when GPT-2 and GPT-3 came out, I was at MIT Technology Review. And then when ChatGPT came out, I was at the Journal, which is a much more mainstream publication. And when I first arrived at the Journal between GPT-3 and ChatGPT, editors still didn't know really what AI was. And then the moment that ChatGPT hit and they started seeing, the Journal's a business publication, so the moment every single reporter started seeing someone using ChatGPT in their vertical of coverage or in their company of coverage, it like got back to the editors, and the editors were like, oh my God, we need to learn this AI thing because every business is using it and we need to cover businesses where they are. And it was also initially a surprising, funny moment for me because I was like, but AI has been around and businesses have been using it for so long. But it's exactly that. Like the accessibility suddenly had like not just the tech team within a business using it, but all the way up to the top executives that maybe had never touched a tech stack before, suddenly playing around with it, using it to write their emails and things like that.
That certainly got a lot of people talking about possible applications as well as the negative. Chelsea, you in your talk mentioned errors that are made in these models and hallucinations and what you can do about this. Are you really optimistic that we can deal with these errors sooner rather than later, or do you think that will really take quite some time?
Yeah, it's a great question. I think that developing models that either don't make these errors in the first place or that are able to refrain from making a prediction when they think they might make a mistake, I think it's a pretty challenging technical question on the research side. And so I think it will take some time to actually allow these models to stop making mistakes or to be able to understand when they're not sure. And that said, I guess there's so many people working on this problem and so many people excited about these models that there at least will be a lot of brain power behind trying to solve those challenges from a technical standpoint. But I do think that it is an open research question and it might take some time. I should also mention that I think that there are applications where errors are a little bit less critical, where these models can already be very useful. For example, if the goal is to make an expert faster at what they do, for example, helping them write emails, helping them write code, then they can proofread that and check what's written such that if there was a mistake made, they can correct that mistake because they're going to be proofreading it and they are an expert. There are also scenarios like Google Translate, for example, that are powered by basically the same kind of technology where it's really useful to get the most common use cases right. That's also a place where it can still be useful even when it's making errors. But even then, the errors that it does make can be very damaging and can be rather problematic as well. So I think that it's a hard technical challenge. I think that it's a problem that we can solve, but I think that it'll take time for the community to solve it.
So I'd like to jump in there and just say that I think that in a technical community, we are all very aware that making these models better has a lot of human in the loop still required. There's loads of people who are setting up all sorts of evaluation sets and asking ChatGPT, for example, questions to figure out what the gaps in its knowledge are or where it gives biased or toxic output. And I think the thing I wish we could see more of is communicating to the general public that this is not a solved problem, because we started this conversation talking about the fact that the thing that made ChatGPT so different is the fact that literally everybody could have access to it. And I wonder if everybody has access to this background knowledge of the fact that, hey, there's so many people who are being paid to make it better, and it's not necessarily just an AI that is already all-knowing.
Yeah, I to add to that point, I completely agree with that, Kathleen. That one of the things that I wish companies that were building these products did more, not just I wish that they communicated about it more, but also I wish they spent more time intentionally designing the user interfaces to communicate about it more. Like OpenAI has a line on the ChatGPT interface that says there may be errors, but that doesn't really tell you enough about what kind of errors, how frequently are they, how severe are they. Like there should be a lot more design intent embedded within the interface that immediately intuitively helps a user understand when they can use it, when they can't use it. And that in and of itself would be, I think, a really effective way to communicate to the public how these technologies should be used.
Are you concerned about the quick take-up of those tools?
I would slightly reframe my concern to, I'm not concerned about how quickly people are uptaking the tools. I'm more concerned at how quickly the tools are being released. Because I think it's natural and potentially exciting that like once the technology is out, that people are like opening up their arms and adopting it and experimenting with it, trying it in different ways. But I do think that the responsibility is on the companies developing these tools to actually make sure that they release them in a more methodical and thoughtful way. So yeah, my concern is more on like the early part of this pipeline from like releasing to uptake. And I think when OpenAI, I mean, ChatGPT was a surprise in terms of how popular it was for many people within the technical community, because we've all seen this progress and it had never, as we mentioned. It was definitely a surprise for OpenAI too. And there are many OpenAI employees who have talked about this, where they just did not anticipate that ChatGPT would become so virally popular. I do think though, once it became clear that that was true, that they should have put some kind of like they should be starting to put like guardrails around it and making sure that it's only used in certain contexts, or maybe like pulling back some of the capabilities to iterate on it more, to fully understand like how it might impact people in different circumstances. But they kind of just stated kind of blanket that, oh, it's a research tool, so like that just means that it can, like, we don't necessarily have any responsibility because we weren't selling it as a product. It's just research, it's just experimental. And I don't actually think that that was the right approach.
I think that ChatGPT is opening up a can of worms for misinformation to go on steroids. It looks to me like the rate at which information can now be generated has grown exponentially. We still don't have a handle on exploring the credibility of content that already exists. Now we have to contend with wondering whether this content is credible, was created by a human, or whether it's AI generated. And I think it then becomes a circle that feeds itself. We already know that majority of the content available on the internet is in English. And I think it goes without saying that a lot of the content that ChatGPT creates and goes back onto the internet is going to be in English. I think this elbows out low resource languages much more. And then I'm again greatly afraid for the misinformation, right? There's a lot of histories which are oral and have not been written down, but now there's a possibility of a ChatGPT creating a history. Who's going to tell us what's true and what's not if it hasn't yet been recorded? Or who's going to tell us what was created by an AI and what was handwritten?
So I'd like to ask you maybe a little bit of a silly question, but it's always fun to ask these questions. So imagine that you were the boss of the world, and so you could tell people what to do, and there would be one thing, one command, one decision that you could make now in this area to help things along, to make things better. What would it be?
I can start. In the age of AI, we rely a lot on data sets. And where data sets are concerned, I've done a lot of work in building data sets, and I see how we could use thousands of people, maybe hundreds of thousands of people as contributors to a data set. But at the end of the day, the ownership is attributed to whoever aggregates the data set. So I think I'm leaning more towards regulation. I'd like to see a change in how we articulate ownership of data sets. I wish that the data subjects could have more ownership. I wish that this ownership could mean decision-making power. I wish that the ownership could mean that they are able to access records of the processing of their data if they wanted it, and that these were readily available. and if the data set is of great value and is making a certain company a lot of money, I wish to see this ownership also mean that either some shared resources that this community created can be maintained using returns from the monetization of the data set, or maybe even the individual owners actually get some return. Because at the end of the day, again, we like to frame AI as something that an elite group of individuals build and therefore control, but then the truth is there's so many people involved in its production in many contexts, and we never really take that back to them.
How about you, Karen?
I was torn between saying that, so I'm so glad that Kate said that. And strengthening labor laws globally, because so much of the conversation of like the impact of AI on society has to intersects with labor, both like the labor that goes into building these systems and the way that it's so easy for the workers, not the AI researchers, but the workers that I talked about in my talk, like the workers in Kenya, to be exploited. But also, once you have these technologies that can in theory replace large swaths of jobs, there's just, I mean, we're seeing the huge protests now in Hollywood where workers feel really squeezed at the bottom of the industry because executives at the top are wondering, can we automate away certain people, or can we pay them less because we don't need their services as much, or what they're offering isn't as unique as like this cheap tool that we get from OpenAI. So it is, I think, one of the ways that I see for getting to a point where we can reap the benefits of AI without also really suppressing like stable employment across the board, across like many facets of society, is to just have really, really strong labor laws that guarantee certain wage minimums, guarantee certain working conditions, certain hours, like having hourly reliable wage pay and benefits. So that is the thing that I would do, in addition to everything that Kathleen said.
Well, Karen and Kathleen and Chelsea, it was just really wonderful to have a little bit more time to talk to you after your presentations and take a deeper dive. Thanks very much. Welcome back. Bienvenidos. Ahlan wa sahlan. It's time for our second thematic block of this conference. 3 10-minute talks on sustainability and the environment, followed by a panel discussion with the 3 speakers. We will later feature talks by Fiorenza Micheli and Marilia Gyarsa, both now in California. And we start with Gopika Suresh, who joins us from Germany. Gopika is a synthetic aperture radar, or SAR expert, who works in marine, coastal, land cover, and disaster response applications. She's also the director of the Sisters of SAR initiative. Global solutions for a global world, latest trends and gaps in the field of Earth observation and remote sensing. Enjoy.
Hi, everybody. Good morning, good afternoon, good evening. My name is Gopika, and I'd like to tell you about the power of Earth observation and how it can be used to provide for global solutions in this wonderfully global world. So I've got 3 topics that I'd like to address. The first is the role of Earth observation in our global world and some latest trends. The second is the gaps in using Earth observation. And the third, what the state of inclusivity in remote sensing and some action plans. Let's start off with what is remote sensing. So the definition is that remote sensing is the science, technology, and art of obtaining information about objects from a distance. So that basically means you do not really need to be there near an object to actually measure it or get information about it. So this basically allows for the retrieval of information of regions that are too expensive, too dangerous, or that are not accessible. What we do is we have sensors or instruments on board of various kinds of platforms. These can be uncrewed aerial vehicles, they can be on cars, they can be on aeroplanes, they can be on the International Space Station or on satellites, like you see here. What we call as Earth observation are data that are provided by satellites orbiting our planet. And because it's data that is from around our planet, observing the Earth, it provides a timely way to tackle global, national, and local challenges. And of course, data science is a big part of Earth observation and remote sensing, because in order to understand the images that we're looking at from these satellites, we do need to do a lot of computer techniques. Since 2015, we live in what we call the golden age of Earth observation. And this is because since 2015, many different space agencies across the globe have released a lot of Earth observation data for free. So what you see here are just the Earth observation satellite fleet from NASA and from the European Space Agency. Around our planet today, there are about 11,000 satellites. Of these, about 5,000 to 6,000 are active. That means they're actually monitored and they actually provide active information. And of these 5,000 to 6,000, about 1,500 are Earth observation satellites that are looking at our planet all the time and giving us amazing information about our planet. And this is why we live in the golden age of EO. So this data can be used to provide global solutions to global challenges. This can be for disaster response, for climate change adaptation, and making solutions, for policy making, for sustainable development. I provided 2 examples here. The upper image shows you sea level change over the last 20 years from satellites that are part of the NASA fleet of satellites. And what you see at the bottom is deforestation from 1992 to 2012 using satellites that are part of the European Space Agency's fleets. This basically shows you that Earth observation satellites can be used to provide this global picture of vulnerable regions, of stable regions, anything but the global perspective. Now, because we can get access to data across the globe, irrespective of borders, this helps in transparency and accountability. So this helps to understand climate change, to reduce carbon footprints, to set reduction targets, for rapid response after natural hazards, for disaster mitigation, for national security issues, for monitoring air quality and pollution. So let me give you just a few examples of the range of applications that Earth observation can be used for. So I started my career working on analyzing deformation after the Haiti earthquake in 2010, while sitting in my office in Germany. So this is the power of Earth observation. I didn't have to apply for a visa. I could just look at the data, and then I could actually analyze deformation after the earthquake. Then I looked at the depths, the deepest ocean floor, to look for oil seeps or hydrocarbon seeps. I was looking at the Gulf of Mexico, and I was looking at the Black Sea using Earth observation data for my PhD. Then I looked at Germany to understand land cover. So all the bright spots here are urban areas, and all the other colors are different kinds of land covers. You can then use a lot of data mining. You can use a lot of data science to extract information about, let's say, how has forest changed over time. And then we are also constantly getting a lot of information about air quality from satellites. Like you see here, this is just the quality of particulate matter over Europe on a particular day in 2019 from Earth observation satellites. So now that we know that Earth observation is really cool, where are the gaps? The first and the biggest gap that I see here is that everybody wants artificial intelligence and machine learning. Everybody wants to get into this, this latest trend, yet to do both of these techniques, you need something called training data. And you do have a lot of training data, but in a few parts of the world, it's not globally available. And that is the biggest gap that I see. So you can do three main techniques for any kind of Earth observation, data analysis. You have the visual analysis. That's the first one you see, where somebody actually sits in front of the computer, looks at these satellite images, and interprets these. The second one is you have the computer do something for you, and then you interpret the results from the computer. That's a semi-automatic technique. And the third one is an automatic technique where somebody actually programs the entire routine in the computer, and the computer does the work for you. That allows you basically for big data analysis. You can then have more techniques like pixel-based, object-based, supervised, unsupervised, and the supervised classification or supervised techniques require training data that is not globally available. We have a lot of free data. Like I said, we're living in the golden age of Earth observation, but all of this data is medium resolution. So when you think about resolution, think about Google Earth. And the closer you zoom in, the more you zoom in, the more you see. And that is the power of resolution. Higher the resolution, the more details you get. So right now, very high resolution data is not affordable by, let's say, science institutions. And we need to now create the accessible age of EO. We're not just in the golden age, but we need to make an accessible age. That basically means we need the cool EO data and the cool data science methods that are producing awesome results to actually be communicated to the right people in the right way. So we need to ask them what they need. That means a farmer in Ethiopia who wants to analyze forest degradation needs to actually be able to understand EO data so that they can use it. So now coming to the topic of inclusivity in remote sensing. There is a lack of representation at all levels. The reason I'm involved in this topic and the reason why I know so much about it is because I am the co-organizer for a voluntary initiative called Sisters Assam. And if you want to read more about it, feel free to go to the website there. But basically our aim and our mission is to showcase women in remote sensing. Remote sensing is a field dominated by men, and we want to make sure that women are represented everywhere. On our website, you'll find a portal where you can find women in our field, you can find what they do, where their expertise is, and basically this provides a place where you can find panelists for your sessions, where you can find potential mentors, anything that you need. We're on Twitter, we're on LinkedIn, we have the website, as I said, and we also work with a lot of other diversity, inclusivity, equity, justice organizations. And one of the things we did is we came up with this paper where we audited 30 different journals to see what is the status of the editorial boards. And we found out that there is a lack of representation and diversity in publishing and leaderships, that editors are men residing basically in 4 countries. And we found that authors with non-Western sounding names like mine, we receive harsher criticism and harsher reviews. And in this field of STEM or remote sensing, where, you know, age indices and citations, they make or break your career, it is quite sad to know that gatekeeping happens at such a level. And yeah, this is one of the things that you'll find in our paper. We also recommend action plans. And this photo here is from another session that we organized at the Living Planet Symposium, which is a big conference. If you just Google Living Planet Symposium and Sisters of Science, you'll find all the information about it. So to conclude, in summary, climate change is here. It's felt globally, but it will affect low to medium income countries the most. I used to watch a lot of Captain Planet as a child, and our Earth is in peril. It's a fact. And Earth observation can help in quick decision making to support all kinds of rapid decision making policies. We need to work together. We need to come together as a planet, as people, as humanity, and make solutions, make training data more accessible, make our field more inclusive. And feel free to get in touch if you want to learn more. And with that, I'd like to thank you for your attention.
Vielen Dank, Opika. Our next speaker in this block is Fiorenza Micheli. She's a professor of marine sciences at Stanford University. Her work at Stanford and in the many nonprofits she supports focuses on marine conservation and climate impacts on marine ecosystems. Enjoy her talk, Harnessing Data and Tech for Ocean Health and Sustainability.
I'm thrilled to be here with you to discuss the opportunities from the data revolutions to support healthier and more sustainable oceans for our planet and for all. The oceans are our life support system on Earth. Oceans provide food for billions of people, regulate climate, support economies, and host a large fraction of the biodiversity of this planet, largely unexplored. At the same time, these important functions are at risk from rising temperatures, marine heat waves, ocean acidification, pollutions, and many other impacts. And one of the main obstacles to developing solutions to this crisis is that we barely scratch the surface of our knowledge of oceans, especially at depth and offshore. Studying oceans is hard. It's difficult, and there's many challenges. However, in the last decades, we've seen a true revolutions in our ability to explore, to discover the oceans, and to track change. And this has been termed the data tsunami for oceans. In the last 20 years, we've learned more about oceans than in the previous century, thanks to advances in environmental sensors, biologging, and satellite tracking, as well as developing artificial intelligence and machine learning. An example of these revolutions come from satellite tracking, particularly the automated information system that mandates boats above 50 meters of length worldwide to carry transponders, trackers, that signal their identity and position every few minutes worldwide. This found data that were collected for a different purpose, specifically safety at sea, have opened up a whole new world in our ability to track what's happening out in the ocean. Because vessels have different behaviors when they're at sea, machine learning advances allow us to use this data to discriminate different ocean uses. For example, seabed mining from fishing, and even different kinds of fishing. And for the first time, we have a global view of fishing at sea. For example, as you see in this map, where fishing is most intense, how it changes through time, how it responds to environmental conditions or global shocks like the global COVID pandemic, for example. This, in turn, has vastly increased our ability to manage these activities, to address major challenges such as illegal and unregulated fishing, and support a more sustainable use of the ocean. So there's great potential in these advances. Another example that I want to discuss comes from exploration of how blue foods, the fish, shellfish, and seaweeds that are grown or harvested from aquatic system might contribute to a more sustainable and a more equitable and healthier global food system. a group of over 100 international scientists came together in an initiative that is called the Blue Food Assessment that address questions around blue foods that range from what might be the potential of blue foods to address malnutrition, nutrient deficiencies that affect nearly 3 billion people worldwide, to the potential of blue foods to provide resilience to the food system under future climate change scenarios, to the environmental footprint that the different pathways for fisheries and aquaculture development might bring. One example of the contribution of data science in this area relates to an assessment of the nutritional benefits of blue foods. Scientists in the assessment assembled the first database of nutritional profiles of over 3,500 different species of seaweeds, fish, and algae from aquatic systems. And this enabled in turn to provide an analysis and synthesis of the content in terms of omega-3 fatty acids, iron, zinc, vitamins of these different foods. And so this analysis highlights, first of all, the huge variability that exists among different species, and also the most valuable species that includes, for example, some shellfish or small pelagic fishes that provide alone in a single serving meet the daily requirements of these important nutrients. So this database and analysis provides decision makers and the public with a really valuable tool for determining which production systems, for example, might be most effective in addressing malnutrition. So this effort, together with the other studies that were conducted as part of the assessment that address climate change, environmental footprints, the role of small-scale holders, were integrated in an online open access tool that enables decision makers to assess the potential of blue foods in meeting 4 policy objectives: reducing nutrient deficiencies, supporting human health, particularly reducing the risk of cardiovascular disease, reducing environmental footprint of food production of the food system, and supporting food production and access under future climate change scenarios. And so this tool enables at a country level scale to examine potential win-wins, for example, supporting the production of foods that meet both the nutritional requirements as well as have a low environmental footprint and are resilient to future climate change. So there are some win-wins that, if leveraged, can provide really important solutions to the food crisis. So we are at a really critical and exciting time in how the data revolution can contribute to ocean health and sustainability. And there are essentially 3 pillars that have seen major developments but need more. The first is an ability to collect data in real time at scales. And so further advances in technologies, for example, are urgently needed. The second pillar is continue to leverage analytical capabilities and advances to extract important insights from these new data streams. And finally, platforms that make these insights accessible to the public and decision makers, and continue to develop advances in data access, transparency, visualization. So it's all hands on deck. There's a need, an opportunity for different fields, different stakeholders to come together to meet this important challenge. This is a time of partnership and collaboration towards a healthier and more sustainable planet. Thank you for listening.
Grazie, Fio. Our final speaker in this block is Marilia Gyarsa, Assistant Professor in Life and Environmental Sciences at UC Merced. Her research focuses on species interaction and biodiversity, and bees. Enjoy her talk titled Untangling Nature's Web, Pollination and the Path to a Sustainable Future. Directly after, we will sit down again with Gopika, Fio and Morelia and learn more about their lives and careers, which took them from India, Italy and Brazil to Germany and California.
Hello, everyone, and thank you all for showing up wherever you are. I appreciate you coming for this talk. It's a real pleasure to be part of this conference and speaking in this panel with these two amazing, incredible scientists. My goal today is to show that our planet is formed by an interconnected web of life, and that by untangling or simplifying the relationships between species with the help of data science, we can help pave the way towards a more sustainable future. So pollination refers to the reproduction of flowering plants, leading to the formation of seeds and fruits. It involves the transfer of pollen grains from the male part of the flower to the female part of the flower. But being unable to move makes the whole job rather tricky, rather difficult for plants. Which is why they rely on animals to perform this crucial role and carry the pollen and carry on their reproduction. There's an enormous diversity of interactions between plants and their flowering animals, and it's estimated that between 75 and 95% of all plants that produce flowers rely on pollinators. And insects are the most important pollinators. But these key interactions and many others, if not all, are endangered. We are currently undergoing a sixth mass extinction event, and increasing evidence suggests that insects are collapsing even quicker than we can describe them. Among all existing insects, bees are some of the most important pollinators, and they follow this sad trend. For example, the rusty-patched bumblebee has seen its range shrink by 90% in the last 20 years. And declines in wild bees have been documented in all regions in the world, and as usual, the data from the Global South is notably lacking. We don't even know which species are there, so we don't even know their population trends. For comparison, we have a very good idea about the population trends for both mammals and birds, of which 91% and 100% of all existing species have been assessed, as you can see here in the green bars on your screen. But the conservation status of the overwhelming majority of the 20,000 bee species is a mystery, given that less than 1% have been evaluated. And the collapse of biodiversity cannot be attributed to any single cause. Instead, populations are confronting multiple simultaneous threats, and here I highlight the most important ones for bees and other insects, which are habitat destruction and landscape modification, climate change, and the widespread use of pesticides. And why does this matter? Why do we care? Well, about 1 out of every 3 bites of food we eat need pollinators, or else we wouldn't be on our plates. Bees also represent an essential food resources for other animals, such as those gorgeous bee eaters found in Kenya, and they play a vital role in sustaining plant populations, including aesthetically significant landscapes such as the symbolic poppy, California poppies. And how do we know all this? Well, you go out to the field or the lab and you do experiments and collect data. We need robust, high-quality data in order to be able to make inferences about the nature around us and understand the underlying processes that create beautiful, diverse ecosystems that we all love and depend upon. And the cool thing about working with bees is that they're only like really nice weather. It cannot be too cold or too windy or too hot, and definitely not raining. So bees are entirely reliant on flowering plants for their survival and for their whole life cycle. So they make a great study system, not only for understanding pollination, but also for understanding other types of interactions more globally, more generally. So what we do is we go out into the field, we identify the plant species, and then we look for bees and other flower visitors. Once we see an animal landing on the flower, we're observing an ecological interaction, which is embedded in an ecological network. So networks are nothing else than a way to simplify a complex system. composed by a set of elements or species, and that enables us to study the flow of energy in ecosystems. From this data, we can start comprehend patterns and establish relationships among the various pieces of information, the various species in a landscape. However, as you can imagine, this type of data requires a significant time and money investment. And for example, sometimes it's really hard to collect this type of data. What would happen to pollinator populations after the removal of a particular plant species, here in X, for example, in our screen? And this is hard to explore because we can, for example, we can remove invasive plant species for the benefit of native plants, a process we call restoration. If we want to understand, for example, how the removal of a particular plant species will affect pollinators that depend on that plant, we have to rely on theory and data science to help us. So one way to model the future trajectories of populations is using a mathematical description of the basic elements that underlie these interactions dynamics, the interactions between plants and pollinators. This relatively simple model enables us to explore how the abundance or the number of individuals in a species is affected by the interaction between plants and pollinators. So here the first term represents changes in abundances, which is what we're interested in. And it's modeled by the intrinsic growth rates of the animals and plants involved in the interaction, the competition, and also the benefit of the mutualistic interaction. And my collaborator, Jordi Bascomte, and I were interested in exploring how pollinator populations would respond to the removal of invasive plant species. So here in the figure, the y-axis is the persistence of pollinator populations, and in the x-axis, we show the communities in which the invasive plant species are absent with the X or present in the both early and late seasons of the flowering plants. And what we found is that for this particular case, the model suggests that the presence of invasive plant species might have a positive effect for pollinators in the late season, when resources may be scarce, since most plants are no longer in flowering. Thus, it's important to account for these hidden effects resulting from the removal of invasive plant species when we're doing restoration. Our study strengthens the importance of considering all aspects of species interactions when taking management decisions. And given that the invasive plant species removed may have represented an important resource for pollinators, so it might be necessary to supplement pollinator populations with additional resources following the removal of invasive plant species. And this result illustrates the power of empirical data coupled with data science and underlies the importance of maintaining diverse plant communities to support the long-term pollinator populations and the services they provide, such as pollination. So after understanding what pollinators need, we can boost their environment, aiming to restore and maintain pollinator populations. For example, this is a quintessential picture of an intensive managed agricultural landscape. This could be anywhere in the world, so not much here for pollinators to interact with. But through restoration practice, by installing native plants, we can transform this landscape into a much more sustainable landscape for pollinators. And a study like this provides a fantastic opportunity to investigate how interactions will establish themselves after disturbances. For example, once a plant starts flowering, some pollinators will be attracted and the interaction network starts to assemble. More plants flower and attract even more pollinators as time passes, and collecting data across this temporal gradient enables us to explore the patterns and mechanisms behind the temporal turnover of species. So using a 10-year data set on plant bee interactions from California, Lauren Bonizio, Clark Kremen, and I were able to explore not only how networks' patterns are changing through time, but also investigate changes at the species level. Here I invite you to please pay attention to the species highlighted in dark green, which is one of the most common species in our study system. And it's possible to see not only the differences in interactions from year to year, from year 1 to 3, but also how their position in the network is changing. This interaction flexibility, what we call interaction flexibility, is a potential mechanism that may enable communities to maintain function in the face of biodiversity threats. So today I gave you a couple of examples that I hope showed you how data science is integral to ecology and the pursuit of sustainability in the context of pollination. It's a super cool field. It's fascinating. And right now, it's a very exciting and important time to be working with ecological networks. And there are lots of outstanding questions that we really don't know the answers to. For example, when you talk about bees, honeybees are usually the first thing that comes to people's mind. However, this is only one species out of the more than 20,000 bee species, and the majority of them are solitary, meaning that there is no division in labor. Solitary bees do everything on their own. They produce offspring, forage for resources, and also build and maintain the nest. So uncovering the ecology of these fascinating solitary bees is one open area of research. An exciting new avenue that I'm starting to work with is using high-resolution, low-cost, and scalable data collection. This is at the forefront of technological advancements, and I think will be a game changer, really bringing ecology into the realm of big data. And finally, high-quality data provides the necessary foundation for sustainable practices. And we need to ensure that, coupled with traditional knowledges, the information we produce can fuel evidence-based insight and can inform policy, management, and conservation decisions. So by untangling nature's web, data science can help us trace a path towards a more sustainable future.
Theo and Gopika and Marilia, it's just so wonderful to have an opportunity to talk to you after your presentations. Thanks very much for being part of this conference. And it's always wonderful to have time to take a bit of a deeper dive in some of the questions that may have come up for the audience as well. And one of the things that people are always interested in is understanding how you ended up where you are. And this panel is very interesting because we have Gopika, who came from India and is now in Germany. And we have Theo, who was born in Italy, and she's now in California. And we have Marilia, who was born in Brazil, then went to Europe and is now back or also here in California. So how did that happen, Marilia? Just starting with you.
I did my whole training in Brazil, my undergrad, my master's, and my PhD. During my PhD, I started traveling. In Brazil, we have this wonderful exchange program from the State Foundation of São Paulo, FAPESP. And I spent a year abroad in New Zealand. Then I came back and did my postdoc at UC Riverside, started working with insects. Then I got a Marie Curie fellowship to work in Switzerland. And that's when I got my job here at UC Merced. So that's when I came back. So it's been wonderful. I've been in touch with lots of different cultures. And I think that's really, really great. You learn a lot just by, interacting with different cultures from different parts of the world. So very lucky.
What about you, Theo? How did you end up where you are?
Yeah, I was struck as a very similar path as Maria was describing, including the fact that I wanted to go to vet school, but then for the same reason that you described, I decided to go into ecology. And I grew up in Italy, and I've always loved nature. I've always spent a lot of time on the coast and at sea. And so I went into natural sciences. I did my undergraduate in Florence. And then when I finished, I was a little stuck because at the time in Italy, it was really difficult to get positions and support and fellowships. So I ended up working for free at the university and supporting myself doing odd jobs. Like I work at the horse racetrack, and unrelated. And then one of the jobs that I got was with the nature documentary company, the television company, and I ended up working for a nature documentary in East Africa. And that opened up lots of opportunities. I then did research there in Kenya on mangrove forest ecosystems. And then at the time I had applied for fellowship. So I went to Australia for a year. I came to the US on a Fulbright and started my PhD. And then I ended up continuing on that path and in marine science and a postdoc, etc. And I ended up at Stanford. So a very circuitous path and lots of turns and changes, but this is where I ended up.
And Gopika, you came from India, you ended up working in Germany. How did you end up in Germany?
So I always wanted to do something with science and with space. So I was watching a lot of Star Trek as a child, and I wanted to be like Spock in Data right from the beginning. And in India, if you're good at science and mathematics, you either become an engineer or a doctor. It's very clear. So I didn't like biology as a child. And so I thought, okay, I'll choose physics, chemistry, maths, and then I'll go on and become an engineer. And at that point, there was no field of space or remote sensing in India. And then in 2003, there was the Columbia disaster where the space shuttle Columbia exploded. And there was Kalpana Chawla, an Indian astronaut, a NASA astronaut, but still of Indian origin. She was on board. And I remember as a child, that was monumental for me because there was a person who looked like me and doing something that I wanted to do. So I knew that, okay, I wanted to always do something with space, but then here in India, there was nothing with space. So I said, I'll go and do a bachelor's in electronics and communication because that would open a few avenues. And then in my sixth semester, I had a subject on satellite navigation and satellite communication, and I knew that was it. Satellites were my path to space. And back then, there was nothing in India. We're talking about 2005. So I knew German because my dad, he was in the Navy and posted in Germany. So I knew a little bit of German. So I thought, okay, might as well look into master degrees in Germany. But I'm an engineer. I then went on to do satellite engineering to build satellites and put them in space. And then there I thought, okay, we have a lot of people launching satellites, but we need people working with the data and communicating results to the people that actually use the data. So then I got into remote sensing, did a PhD, stayed in academia for a long time, wanted to do the whole, postdoc, PI, professor thing, didn't work out because of COVID, baby, everything else. And I never thought I would launch my own big data satellite company, but that also recently happened. So it's all falling, the universe has a way of just falling into a certain pattern that gives you success at the end and you make the best of it. So yeah, that's my story.
Now for some of you at the intersection of a domain like oceanography, ocean sciences and data, and for Gopika as a data generator and observer, what has been for you the most surprising and most exciting development in data science that has helped you or your colleagues in the field?
Yes, maybe my experience is a little different, but for me, kind of the revolution happened many years ago, over 20 years, when as a field ecologist, someone who spends their time in the field, rubber boots, wetsuits, doing experiments, I came in contact with a new center that the National Science Foundation had funded in Santa Barbara, the National Center for Ecological Analysis and Synthesis. And that was a revolution in ecology, I think, that happened. There's many others, but basically that center brought together ecologists with data scientists. And the research that I ended up doing there as a postdoc and as part of working groups leveraged the many disparate studies that are done in ecology to bring them together and create general insights through meta-analysis and other techniques that came from the social and medical sciences. So that, as well as development in metadata standards and data sharing and time series analysis, really kind of unleash the potential that ecology can have to generate patterns and insights that are broadly significant. So that, to me, was the revolution. Recently, the development, Gopika in satellite, remote sensing combined with machine learning, artificial intelligence, I think is the new revolution that is happening in my field in ecology and conservation, sustainability, and for oceans.
The NCS in Santa Barbara was a huge game changer. And more recently, I would totally agree. It's the AI and the different applications, even for basic science, trying to identify species. AI has been people are really trying to use AI you can take a photo I work with bees of a bee and it tells you exactly which species it is. There's iNaturalist as well, which is really cool for that, helping you identify and bring more data into into distributions and species abundances and things like that. And yeah, I think AI and just the expansion of computer power as well. So you can just model more and more and try to gather more data. I think with now technology is becoming cheaper and cheaper to build things like sensors and cameras and all that. That's gonna really, I think, and the next revolution is we're living through the next revolution in terms of how much data we're going to be able to gather from nature. And I think it's going to be hard to figure out when is enough now, because there is a point when you have to stop gathering the data and really sit down and analyze it.
No, I wanted to on a point that Marilia made about the importance of citizen science. iNaturalist, eOcean, Sharp Pulse, all of these platforms that really draw on. It's to the earlier point. There's all of this distributed knowledge and resources, and data science advances are really allowing us to leverage them better, bring them together. Still many gaps, especially in ocean systems, I would say. There's a lot of gaps in knowledge, but I think citizen science combined with AI is one of these incredibly exciting developments that we can leverage more.
I wanted to touch on what you said, Marilia, about when do you know you have enough data? Because I think in the field of remote sensing, ever since Copernicus launched all of its free data, and ever since Landsat got free data, we've had an immense amount of big data. We've reached a point where we have so much of data around the world that even computing power is not enough right now. So we're dealing really with, we have too much data, but what does it say, like you say? And that's the biggest trend that I see happening. More and more companies, more and more universities are changing their strategy to, initially back then, remote sensing used to be land cover analysis with using one image. Now it's land cover analysis over the last 50 years using 50 years data where they use 5,000 images or more. And universities are slowly changing their strategy from just results to what do we see in the results and how can you combine this with the different fields. And I think one trend is this transdisciplinary, multidisciplinary thing. It's very fluid right now. Where does ecology end and where does remote sensing start?
Where are you all hoping that your particular domain will be in 10 years from now? You're all mentioning that you're excited. You think there is maybe another revolution happening. Where do you think, where are your hopes going?
I mean, for
Theo.
me, the vision, sorry, I was sorry, but for me, the vision is really one of scaling and putting data science and its capacity, the insights in the hands of everyone. I think that oceans are big, huge, lots of coastlines, lots of communities that are deeply dependent on oceans, profoundly affected by its changes, and empowering those communities to track change, to make decisions that are informed by data, to have access to data or information, lots of different forms. It's really the exciting revolution that is happening through frugal science and democratization of science and access to technology, and to the advances in data science that are making analytical capabilities, visualization more accessible. That is what I hope.
For me,
an ocean for all through data science.
Great.
For me, I think Sorry.
Okay, dream.
For me, I think it's really communication. So that also is what you said, Theo, that at the end of it, the results, the needs of everybody needs to be communicated. The results of what science is today doing needs to be communicated in a way that the people can really use the information to make quick decisions, to make important policy changes, to really preserve our planet. So it's really like we are on one planet and everybody is affected. And we also need a lot of diversity in this because, we need the voices of everybody represented to solve this global problem. So we have big data, we have the computing power, but we need diverse voices to tell us what's happening around the world.
And then we need to communicate it to everybody around so that people are not lost when they need to make really quick decisions about wildfires, about sea level changes, about tsunamis coming, about everything that's happening around the world that is causing pain. So, and also happiness. I mean, there is everything, both, but we need to communicate this in a proper way.
Yeah, I agree. And I've been noticing a big change, I think, in also even in for grants, for funding agencies, now it's all required to have outreach, to involve the local communities, to involve traditional knowledges. And I think that's a really important change that happened. And I hope that in 10 years from now, that means that all the science we're producing are actually being applied and being useful for society. Not that all science, science is always useful, but in a sense that, for example, you can produce food because we know exactly, thinking about my work, we know exactly what plants attract more pollinators, and that in turn is going to improve your crop yield in your little farm in the back of your house, and not only for agricultural familiar agriculture, but also for larger landscapes as well.
Oh, you have all touched on climate change. It's one of the areas that a lot of us, of course, are very concerned about. We've just had a summer here in the Northern Hemisphere with quite a lot of extreme weather events. But I wanted to ask you not what concerns you about this, but I wanted to end this panel by asking what gives you hope from your own field around climate change. To end this on a positive note, really curious to hear.
If I may start, I think on a positive note, what's happening is that people are really proactively working together to solve this global problem. Solutions are being made that can be developed rapidly based on scientific facts and not just long-term plans that would take a long time. So today we need rapid actions, we need informed decisions, and I think that can only be made because of people coming together.
Yeah, you have the last word, Marilia.
Oh no, that's too much pressure. I was gonna say, I think also I totally agree with Gopika and Theo, and I would also add, I think this new generation is also more aware than, for example, my generation is or was, I don't know, about climate change. And I think we're still making slow progress, but we are making progress. And I think if you think about 10 years ago, there was even slower progress. So I think we're making faster progress, even though I do think it's still very slow, but I think it's changing. And because it's so dramatic right now, right? You can really see, I mean, we had a tropical storm in California for the first time ever. We have, I was just reading that the emperor penguins had a terrible breeding year because of the ice. There was not enough ice for them to breed. So we're seeing like terrible things happen right now. So I think this urgency is bringing fast changes. And I'm optimistic. We'll see. Maybe we should redo this panel in 5 years and see whether we're still optimistic.
You're on. Let's do that. And thank you so much, all of you, again, for being part of Wits on this September 14th. Your talks, wonderful, lots of fantastic insights, and really nice to chat a little bit longer and get some deeper insights. And everyone, thanks for joining us. I'm really excited to introduce you to our second keynote, Your Brain on Art, How the Arts Transform Us, with Ivy Ross and Susan McSalmon. Their talk is based on the wonderful book with the same title they authored together recently. Ivy is the Vice President of Design for the hardware organization at Google, and prior she held executive positions and presidencies of several companies, including Calvin Klein, Swatch, Mattel, and Gap. She is also a renowned artist, and her work is in the permanent collections of 12 international museums. Susan is the founder and executive director of the International Arts Plus Mind Lab at Johns Hopkins University. Her body of work lies at the intersection of brain sciences and the arts, and how our unique response to aesthetic experiences can amplify human potential. I hope you will be inspired by their keynote, in which Ivy and Susan give data-based evidence for the positive impact arts can have on our lives and on our work as data scientists.
Hi, I'm Ivy.
And I'm Susan, and we're thrilled to be here.
We believe we're standing on the verge of a cultural shift in which the arts can deliver potent, accessible, proven health and well-being solutions to billions of people. You know, there's a new paradigm emerging where the arts are being used to humanize medicine, education, and business, and where data science will continue to play an important role in moving humanity forward. So we all need to develop more holistic skills that embrace the arts and humanities, feeling our way into the future, because we're literally wired for art. When we talk about art, we are including all of the arts: theater, dance, singing, music, visual arts, digital arts, architecture, and so much more. We've been optimizing for productivity since the Industrial Revolution, pushing the arts aside because we were told either we were not good enough or questioned the relevancy to our careers, thinking that the focus mostly on productivity and efficiency would make us both successful and happy. But we all know we're not.
This is an image of a Colombian cave rock painting that represents the experiences of daily life. To better understand how we got to this point in history, the two of us began to think deeply about the role of the arts and aesthetics once played in our lives. We humans are both makers and beholders since the beginning of time, and the arts and aesthetic experiences in all their forms have been used for many purposes: self-expression, communications, collaboration, reflection, healing, and flourishing. They are our birthright. We spoke with E.O. Wilson, the Harvard evolutionary biologist, who shared that the art making was essential to the development of us as a species. Biologically, we learn to make art and to be moved by aesthetics by connecting to our senses using sight, sound, touch, smell, and taste. You visually process 34,000 different pieces of information in a single hour. Over your lifetime, you'll process some 24 million different images. Each of your fingertips have over 3,000 touch receptors that rapidly change your neurophysiology by releasing a cascade of neurotransmitters like serotonin and dopamine. Your nose can detect 1 trillion odors and it has over 400 types of scent receptors, and the cells renew every 30 to 60 days. Sound becomes an excellent tool to help regulate stress. And in this case, it works on an unconscious level. The frequency of sound instantly taps into what underlies beneath your conscious recognition, literally changing the vibrations in your body. We believe that it's essential to come back to our senses, to enliven us and expand our capabilities as whole human beings.
You know, the ancients knew what Julie Bolte Taylor, a neuroanatomist, is telling us here in this quote. Most of us think of ourselves as thinking creatures that feel, but we are actually feeling creatures that think. We now know that we experience over 34,000 different feelings. And so in the spring of 2019, the two of us had the opportunity to put these neuroaesthetic principles into action in real time to illustrate the effects of sensory perceptions on our bodies in an exhibit called A Space for Being. This came to life through a collaboration with Google, Susan's lab at Hopkins, and architect Suchi Reddy. Participants walked into a space where they were fitted with a custom band containing sensors that were continuously taking in biological information, including body temperature, variable heart rate, and pulse. Participants were invited to touch, smell, listen, and explore for 5 minutes in 3 different rooms with no talking, no devices, no photos. Each of the 3 rooms were designed with a different set of neuroaesthetic principles that affected the choice of colors, textures, materials, shapes, music, scent, and lighting. At the end of the experience, guests had their bands removed by a band tender, and their data was downloaded for them only, and of course deleted after we shared the information with them. Each visitor received a personalized data visualization revealing in which space their bodies felt the most at ease or most relaxed. This conclusion was based on their real-time biological feedback being fed into the algorithm that we developed. And as predicted, in over 56% of the people, the room they liked the best was not necessarily the one in which their body felt the most at ease. The point is that the body is feeling all the time and our mind is not necessarily connected. The experiment was a success as we were able to show that what we think is not necessarily what we feel, and our body is feeling all the time through our senses.
As Ivy mentioned, the exhibition was the first time the public experienced the science of neuroaesthetics or neuroarts in action. This is an emerging interdisciplinary field that has exploded over the last 20 years because technology has allowed us to get inside our heads and study the extraordinary ways the arts and aesthetics impact us. Neuroarts is the study of how arts and aesthetics measurably change your brain and body, and how this knowledge can be translated into practices that advance health and well-being. Research is proving that we are literally wired for art, and these experiences alter a complex physiological network of interconnected systems, both neurological and biological. The arts literally engage every system in your body, and the implications for this are profound. How these systems connect and change happens through a process called neuroplasticity. Each of us are born with 100 billion neurons that connect at a synaptic level. You have quadrillions of connections in your brain, creating endless neural pathways. These pathways underlie your body movements, emotions, memories, basically everything that you do. When you're making a memory or learning something, you're actually making some synaptic connections stronger and some weaker through the saliency of your experiences. In this way, you're actually sculpting new pathways that have not been there before and encoding a new memory and changing your brain. As we showed in A Space for Being, your body, your entire body, not just your brain, takes in the outside world, but much of it sits outside of your awareness. You're only conscious of about 5% of your mental activities. The rest of your experiences, physical, emotional, and sensorial, live below what you're actually thinking. But you couldn't possibly pay attention to all the sensory stimuli that's coming into your body or the many emotions and thoughts that emerge. Your brain filters out the inputs that seem irrelevant and focuses its attention on what it believes to be pertinent, and in fact prunes or deletes what's no longer relevant. What is salient to you is important to you, either for practical or emotional reasons, and the arts and aesthetics are some of the most salient experiences. This salient information enters your body and has unlimited capacity to change and enhance your cognition, emotions, perspective, mood, decision-making, and so much more. So why should the arts and aesthetics matter to data scientists and to the field? Your field is exploding. Over the next 10 years, employment of data scientists is projected to grow by 36%, faster than any other occupation. You are at the forefront of new advances in technology. You're meaning makers of enormous amounts of information, and you're storytellers. Your skills to use data to analyze, understand complexity, influence others is unparalleled and will only increase as advances in technology continue to accelerate. You are in a unique position to use data science in service of humanity by expanding your cognitive and emotional capacities to meet the imperatives that are before us. The good news is business, government, education, and other sectors are beginning to understand that building skills through the arts and aesthetic experiences are not a nice to have, but that they are essential.
To zoom in on why the arts and aesthetics are important to you individually as a data scientist, here is some compelling evidence-based findings to consider. The good news is you don't have to be proficient at the arts for them to have significant impact on you as a maker, and you also gain valuable benefits even if you're just a beholder of the arts. So let's start with mental health. Here are just a few examples. Research is proving that people who engaged in the arts were found to have lower mental distress, higher mental functioning, and improved quality of life. Music played at certain frequencies decreases levels of cortisol, a hormonal marker of stress, while increasing oxytocin, a hormone sometimes used to treat depression and anxiety. And studies show that dancing for even just 15 minutes reduces anxiety and increases feel-good hormones, including endorphins, serotonin, and dopamine, to name a few. And also dancing is highly effective in creating new neural connections. And believe it or not, working on an art project for 45 minutes, regardless of skill, reduces stress by 25%. The arts and aesthetics also increase your cognitive skills. Musical training improves visual spatial abilities, executive functioning, and memory in adults with specific neurological pathways supporting these effects. Participation in visual arts and dance improved pattern recognition and observation skills, as well as skills in emotional recognition, cultivation of empathy, identification of story and narrative, and awareness of multiple perspectives, which is so important today. Engaging in dance practices improves neuroplasticity, including significant increase in cognitive function, memory, and attention. And classical music significantly increases working memory compared with no music. You know, researchers coined the term the Mozart effect after finding that listening to 10 minutes of Mozart resulted in improved spatial temporal reasoning. Art practices also increases synapses and gray matter, which supports cognitive skills, and even doodling increases attention and focus, retention, recall, and consolidation of memories. So start doodling in all your meetings. Making art increases the speed of cognitive processing. Who wouldn't want faster processing? And arts increases, of course, your capacity for imagination and creative thinking. We're beginning to understand how our brains can turn off portions of the prefrontal cortex to achieve these flow states, which does improve overall well-being. And expressive writing increases our ability to form complex ideas and articulate emotions and feelings, which are so important. And reading poetry lights up some of the same parts of your brain as listening to music does, stimulating your primary reward circuitry and activating reflection and introspection. And what's so incredible is that skills learned through both arts making and beholding transfer to many other areas in our lives.
When we zoom out and look at the collective value to the field and societal benefits, they're exponential. The arts have the ability to improve numerous outcomes related to the field of data science. They can improve pro-social skills, including empathy, trust, and compassion, problem-solving skills, including creativity, reflection, and critical thinking. Additionally, the arts have been used as a tool to teach data science concepts and improve data literacy. So here are just a couple of collective values. Listening to music has positive effects on people that can make them more tolerant, empathetic, and generous. Empathetic responses to paintings are a result of mirror neurons, which engage emotional circuitry of joy, fear, or anger to mirror the emotions expressed in that artwork. Appreciation of art has also been seen to increase inspiration and creativity, and participants who engage in appreciating works of art are better able to generate creative solutions and show enhanced performance. The arts can enhance reflective thinking, which can also in turn improve decision-making and problem-solving processes on multiple levels for critical thinking. And even dancing can trigger our social brains to connect and bond. And this propensity for synchronicity is something that we innately do as humans. Storytelling can be used to present creative ideas and to build creative thinking and problem-solving skills. The arts can improve creative communications and foster leadership skills. And finally, epidemiologists are also showing that when we engage in arts experiences as makers or beholders, we make better decisions throughout our lives.
The arts can expand the field of data science to see the entire picture of possibilities. So please, if you haven't already, in addition to good nutrition, sleep, exercise, and those important data deep dives, add the arts in your life for both the benefit and well-being of yourselves as well as humanity. These arts and aesthetic experiences help us know and feel the wholeness of what it is to be human. Thank you.
Thanks so much, Susan and Ivy, for inspiring us to stay or become active in the arts as data scientists. We will now feature a short 3.5-minute video that Ivy and Susan and their colleagues recorded in 2019 at the Milan Design Week. It shows an installation built by the Google Hardware Design Studio to study the effect space design has on all of us and our biology. After this video, we will have a 2-minute break. Don't go away. No te vayas.
The way this project is unusual is that we are actually pursuing a principle. I really believe that form follows feeling, and feeling is really what space and architecture are about. Space actually affects people.
Design matters. It's why we spend the time making the decisions we do. Those things that we as designers intuit, neuroscience is now proving have an effect. Google created an exhibition that is showing design's impact on our biology.
The way that I explain neuroaesthetics is really simple. It's basically how your brain changes on the arts. When you have a heightened aesthetic experience, like a piece of music, a sunrise, things that really elevate your everyday experiences, they change you. They change your biology, they change your mood, they change your emotion.
I called Suchi Reddy and I said, taking the neuroaesthetic principles, could you create 3 different rooms that would evoke different responses?
The goal is to see how people resonate with space and to really find out whether what they think they resonate with is what their body is actually resonating with.
We respond to the aesthetics of our environments, whether we realize it or not. The band can demonstrate with data from the sensors that actually is happening. Heart activity, respiratory activity, skin temperature, skin conductance. We figure out from the data which room is the one that feels the calmest or the most at ease for people.
Where does your physiology feel most peaceful? I think it's what people are searching for. The space between the notes, the place where they can come and just be.
The interiors where we work and where we live have a deep impact on our well-being. We've always known it and believed in it, but we haven't been able to quantify it and prove it. You enter a space and it's like, I like it, but why?
This is about data used as a mirror back to yourself. Data is just a bunch of numbers, and we wanted to make it artistic in its expression.
It can be really hard to put an aesthetic experience into words. But suddenly by combining science and technology, we get a new language.
We've selected room 2 as the room that you were the most common.
Maybe a watercolor can tell more than 1,000 words.
technology has the ability to help you know yourself better. The problems of the future are only going to become more complicated. Solutions have to happen in this collaboration of technology, the arts, and science.
Welcome back. The Wits Datathon has grown into one of our largest annual programs. We will soon launch our 2024 Datathons. Yes, there will be more than one. We'd like to now show you 2 short Datathon videos. The first recaps this year, and in the second, team members Chisu, Valerie, and Sharada unveil next year challenges.
Since 2019, the Wits Datathon has helped women worldwide discover and hone their data science skills through solving an important social impact challenge. We at Climate Change AI have been thrilled to collaborate with WiDS for the past 2 years, with the 2022 challenge focused on predicting buildings' energy use to improve their efficiency, and with the 2023 challenge focused on improving medium-term weather forecasts to help us adapt to climate extremes. It was wonderful to see so many participants, 4,000 from 100 countries in this last edition, working towards addressing these impactful problems.
We were so inspired to see several high school students participating in this year's challenge. So the top high school award goes to Zainab. She is from Saratoga High School.
With Datathon 2023 has been my highlight. Considering it was my first one, the collaboration was just awesome.
I've been participating in Wits Datathons for 2 years in a row now, and what I like the most about it is how they provide all the participants with these unique data sets that most of the time are hard to get. So I think joining this kind of datathons actually make you feel part of something bigger. I feel like if you don't know where to start, these kind of datathons are a really great place to begin. The Datathon provides a great sense of community to all of its participants, even within our course itself, which was offered to both undergraduate and graduate students. We have a lot of diversity in the background and departments represented, and as a result, we had a very unique community of diverse ideas and skill sets, and also networking opportunities.
The student feedback was that it felt like a real data set. They didn't just get to plug it into an XGBoost, they had to do a little bit of pre-processing, which really increased their confidence to work with real-world data.
For the 2024 Women in Data Science Datathon Challenge, I'm thrilled to announce our collaboration with Gilead Sciences and our data partner, Health Verity. This year's challenge will be focused on equity in healthcare with a focus on oncology. Now, why is health equity important? Health equity is important because the US population is becoming increasingly diverse, and we at Gilead want to ensure that we understand the key barriers associated with access to care. So let us come together as a data science community to leverage machine learning to identify barriers that prevent individuals from receiving the appropriate care, let's advocate for change, and work tirelessly to eliminate cancer-related disparities. With a steadfast commitment to health equity, we can make a profound impact on the lives of individuals and communities affected by cancer. Thank you.
My advice to future Datathon participants would be to take advantage of these regional events. Join them, meet new people, learn together with other participants, because Datathon is all about learning new skills and having fun.
Do you want to hone your data science skills and learn about equity in health? Why not join us for the 7th annual Wits Datathon? The Wits Datathon is for everyone worldwide to participate.
We created the Wits Datathon to solve social challenges with data science approaches. Wits provides a very supportive environment for everyone to connect, learn from each other, and have a lot of fun. We are thrilled to announce a new advanced edition for university instructors to use the Datathon in their classroom. This will be available in addition to the global Datathon that is for all levels. We are really excited to partner with Gilead Sciences to provide this year's datasets.
This year's challenge is based on breast cancer. We partnered with Gilead Sciences to provide a rich and complex oncology dataset underlying this year's predicted challenges. The challenge will focus on different variables of breast cancer treatment. The variables include time to treatment, access to cancer drugs, then demographic and economic factors. For the University Datathon, you can expect to work with a dataset containing real-world data issues such as missing values. For the Global Datathon, you can expect a relatively clean dataset. Whichever challenge you choose, we look forward to your contributions.
Sign up now for the 2024 Wits Datathon.
I look forward to the next thematic block of this conference. 3 10-minute talks on health and safety, followed by a short panel with the 3 speakers. We will feature talks by Rima Vaidyanathan and Paula Petroni, who join us from New Zealand and Spain. We start with Sparkle Russell-Polleri, the Director for Clinical Data Sciences, Advanced Analytics and Oncology at Gilead Sciences. She joins us from the Bay Area in California. Sparkle is an expert in building AI and ML-based solutions to help increase clinical trial efficiency across the pharmaceutical, biotech, and medical devices industries. Enjoy her talk on data science in the healthcare and life sciences industry.
Hi, my name is Sparkle Russell-Polleri, and I'm a Director of Data Science, specifically in the oncology area at Gilead Sciences. Today, my talk will focus on data science in the healthcare and life sciences industry. So who's Gilead? Who are we? Now, Gilead was started in 1987 by Michael Riordan
And it was named after the famous playwright's play called The Beam of Gilead. So if you do a quick Wikipedia search, what you will see is that a gilead is a rare plant that possesses medicinal properties. So we exist for the same purpose, to bring new hope in the face of devastating disease. And for more than 36 years, Gilead has discovered, developed, and delivered innovative medicines in the areas of great medical need. Now, our ability to translate science into once impossible advances has led to the commercialization of more than 29 life-changing therapies across 3 core therapeutic areas. These areas include virology, where we hope to end the HIV epidemic for everyone, everywhere. Oncology, where we hope to deliver transformative therapies in 20+ indications, impacting about 400,000 patients. And inflammation, where we hope to advance new treatments to help improve people living with a range of inflammatory and fibrostic diseases. Now, where are we going? We tend to go where there is great need. And our given philosophy, as you can see, is centered around removing and eliminating these disparities. So how are we doing that? Well, it starts with the numbers. So on the left, you can see 87% of the people surveyed believe that there's still a stigma around HIV. And 25% of the people who can benefit from PrEP for HIV prevention are currently taking it. And last but not least, Black women have a 40% higher breast cancer mortality rate than white women. So we are working to focus on eliminating these disparities by focusing on what we call the 3 C's. So care. How do we remove barriers to care and well-being for individuals who face economic, social, and geographic hardships? Capacity. How do we build the infrastructure to be able to promote health and create sustainable, self-sustaining community-based organizations to be able to then deliver the care back at the local level to drive the change that we're looking for? And last but not least, change. How do we advocate for change, for social change, by addressing the social determinants and the root cause of health, from education, inequity, to stigma, etc. So how do we do data science? It's a key part of it. We need the data to understand how to address these issues. So at Gilead, data science is focused on 4 key pillars: talent, data, technology, and obviously once you have the first 3, you can use fit-for-purpose analytic methods to help it drive insight generation from these data sets. So first off, talent. Our data science community has over 1,200 data professionals. And that's not just the data professionals who are building the fancy algorithms, but the folks that understand the deep domain or can possess the deep domain knowledge that is needed to develop the research questions to answer these difficult questions that we're trying to solve, to the folks that are taking and ingesting our data, creating the data pipelines that makes it easier for a data science to be able to analyze data sets downstream. So what type of people do we hire? So we hire from some of the best minds from a diverse array of disciplines. And these fields of studies can range from chemical engineering to biomedical engineering, physics, mathematics, epidemiology, etc., all of who come with their own deep domain expertise, but are either understanding of how they apply these newer methods or are willing to learn how to apply new methods within their domain for us to answer these difficult research questions. And obviously, as a data scientist, you need the data itself. So we are invested in the right data sets to help drive these new insight generation. So while we do generate our own internal clinical trial data sets across the drug development process, we also do need access to real-world data sets to give us a better glimpse of how patients are responding in the real-world setting. So beyond just saying I have a clinical trial and I have patients in there, what happens to the patients who were not involved in the clinical trial? How are they responding when our drugs get into the real-world setting? So to get to the crux of that question, we tend to look at it from a patient-centered view. How do we create a holistic view of how patients are responding to our drugs? And that means we have to tap into multimodal data sets. So in the case of imaging, how do we use radiographic images such as PET, CT, and MRI to identify pathologies in images and quantify them? How do we leverage genetics to not only assess which genes are involved in or associated with a disease, but also which gene variants are allowing an individual not to respond to a specific treatment? And then electronic health records, how do we look at the person's routine checkups to understand how they're responding to treatment, Or how do we understand which patients could benefit from our drugs that weren't part of our clinical trial in a real-world setting? From pathology, how do we use digital pathology methods or pathology as a whole to assess and classify disease? And last but not least, what about getting that real-time data? A lot of these data sets are captured in one single snapshot in time. How about using real-time technology, wearable technology that will give us the ability to capture data at every second so we could get a 360 view of truly what's happening to a patient in their real-world setting. And technology. So we have to leverage, and technology is always evolving, but we have to leverage technology and the necessary tools and able to allow a data scientist to tap into the data sets and extract these insights. So what does this look like? Typically, traditionally, the pharmaceutical industry has typically worked on SaaS-related products for regulatory purposes. But over the last 10 plus years, they've been embracing open source tools, starting with R, and that has since evolved to more of the open source tools and frameworks that's used for machine learning, etc. So as you can see, our tech stack is constantly evolving, and this by no means is an exhaustive list of the tools that we use at Gilead. And last but not least, analytics. So how do we take talent, data, and technology, couple that with the data, obviously, and the deep insights to use these analytic methods to drive insight generation? So as you can tell, there's a plethora of approaches that you could use, from inferential statistics to understand how effective our treatments are, named entity recognition, where we can find out and tag data sets or rich text data sets that we have internally to improve our clinical operations efficiency, image analysis to not only just use computer vision, but how do we understand what's happening in the images itself? How do we quantify that? And then how do we couple that with fit for purpose advanced methods in the computer vision space to identify tumors, for example, genomic analysis to understand which genes are upregulated or downregulated, and the list goes on. So with that, I'm happy to announce the Women in Data Science Datathon 2024 Challenge, where we're hoping to focus on the use of machine learning to predict health disparities in women with triple-negative breast cancer. So what is triple-negative breast cancer? Triple-negative breast cancer is an aggressive subtype of breast cancer. And while it is molecularly heterogeneous, the incidence rate of triple-negative breast cancer is disproportionately higher in women of color. And this means that they tend to have earlier onset of the disease. They tend to be more advanced at the first diagnosis, and they tend to have tumor phenotypes that are more aggressive, leading to huge health disparities. So what does it mean in terms of numbers? Approximately 1 million breast cancer cases are diagnosed annually, and this is globally. But 1 in 5 of those women account for triple-negative breast cancer. And depending on where you read in the literature, that could be anywhere from 15 to 20% of all breast cancer cases. So what are the risk factors? The risk factors include genetics. So women with BRCA1 mutation are at higher risk of developing triple-negative breast cancer. Ethnicity, women of Latino, Caribbean, and African American descent are at higher risk of developing triple-negative breast cancer compared to their white counterparts. And last but not least, age. Women under the age of 40 years are more likely to develop triple-negative breast cancer. So can we leverage machine learning to identify the key social determinants of access to care in this case? So who gets access to care and how long does it take? So in this case, the data that we're going to use was through a partnership we had with HealthVerity, who has a large array of de-identified, over 150 billion de-identified transactions across 300 million patients. And this data source comes from an array of sources, so claims, labs, electronic records, which as you can tell is quite rich. And can we leverage these machine learning methods to predict who has a higher access to care? So how long does it take one patient group to get access to care versus the other? And the insights extracted from that, what can it tell us about the patient population? For example, is there a correlation between access and disease prognosis? And who are these patient populations that have better or worse access? And as always, it takes a village to do this sort of work. So I want to thank all of my collaborators listed here for their tirelessly working for us over the last 2 months to get these data sets ready to answer this challenging question. Thank you.
Thanks very much, Sparkle. Next is Rima Vaidyanathan. Professor of Economics at Auckland University of Technology in New Zealand and Director of the Center for Social Data Analytics. She asks in this talk, can algorithms reduce bias? And she provides evidence from child welfare and homelessness systems. Ka koa!
Thanks, Margot. It's a great pleasure to be here. I'm going to talk about the use of predictive risk models or algorithms in quite a contentious space, which is in child protection and child welfare. So I'm a director of the Center for Social Data Analytics. We build predictive tools for human services, and most of my work is looking at child protection systems and more recently in homelessness systems. So our tools are currently being used in a bunch of states across the US and also in a few other countries. And the challenge for us is to also verify whether the use of these tools have improved outcomes for families and children. And that's what I'm going to talk about. In particular, have they exacerbated or mitigated against racial bias in child protection systems? So the type of work I do at the moment is deploying what we call child welfare screening tools. So what's the problem this tool is trying to help? There are around 4 million reports that are made every year in the US that a child is being maltreated. So those calls come in from teachers, from the community, from counselors, and they typically go to the state hotline. And around 4 million calls have been trawled through by call screening workers who are usually set up in local offices. And they have to decide whether that call warrants further investigation or whether that call can be ignored, which is sometimes called screened out. So you can imagine how challenging it is. In the US, typically, and this is true about Australia, New Zealand, and other countries I worked in, around 50% of calls that come into those hotlines are screened out. So why do we screen them out? Because an investigation is actually quite a thing. It's quite onerous on families as well as quite expensive for the system. An investigation means that someone goes out and meets the family, meets teachers, asks questions, and tries to figure out whether the allegation that was reported about maltreatment can be substantiated. So the question we always have is that 50% being screened out the right 50%? And in fact, you can answer two ways. First of all, we can think we're screening in or investigating far too many children. Did you know that 1 in 3 American children are investigated by the age of 18? Only 15% of those investigations are substantiated. And this rate is 50% for Black children. So 1 in 2 African American or Black children in the US will be subject to that onerous investigation by the age of 18. So from some points of view, we might think, yes, we're investigating too many children. But from other points of view, we might think we're not investigating enough. More than half the children who died of abuse and neglect, at least in the counties that I worked in, have never been investigated. And most of you who might be living in large cities around the world will frequently see on their front pages of their newspapers tragic cases of children being abused and even killed by family or perpetrators, and no one having been investigated for it prior to that tragedy. So why are we not getting it right? Well, the decision that workers are making at that front line, that local office in your neighborhood where people are sitting and fielding these calls, are making incredibly stressful decisions. ethnographic information collected on frontline workers working in call screening claim it's one of the most stressful because you have around 10 minutes to decide whether you'll go out on a call and subject a family, sometimes needlessly, to an investigation, or you'll screen them out and perhaps that child continues to be maltreated whilst we wait for the next call. So one of the challenges that our tools are trying to address is a debate in human decision-making between people who support what's sometimes called naturalistic decision-making, which says that humans have amazing intuition. They're able to intuit the referral that has those high risk factors and poor safety profile from the ones where there's much more evidence of safety and protective factors. However, those of us, and I call myself one of these, in the heuristic and bias area, we think that humans have a challenge because sometimes they are using mental shortcuts to try to support their decisions. They are not reviewing all of the relevant information because when you're under stress and when you have to make high stakes decisions in short periods of time, people will often suffer from heuristic or mental shortcuts. So what we've done is augmented that decision-making for those frontline workers by offering what we in part of the data science work called predictive risk models. So predictive risk models are very simple automated risk scoring, which identifies children at risk of long arc risk of abuse and neglect. We use administrative data so that worker is not being required to complete any forms, and it predicts if the child will be removed within 2 years. So what we've done is I'm going to report now on a couple of evaluations of the use of that tool. So the worker is now making decisions, but is seeing a score. The score is a score from 1 to 20. So the first study I'm going to share with you is one that was conducted in Allegheny County, which is Pittsburgh. We wanted to understand whether showing a screener a tool like this, which basically scores the child that's being called in on a very low risk to a very high risk of being removed within 2 years and also being involved in injury, hospitalizations, and other outcomes that we validated this tool for, whether that changes how screeners act. So screeners were able to so-called override this tool, but they were given this screen when they tried to make that very crucial decision. First of all, you're going to ask me, yes, but was the score predictive? And the score was reasonably predictive of removals in the next 2 years, which means that the child was being abused or neglected so severely that they had to be removed from the family. So now what we see here is just one of the research results that we have found in our study. So what I'm showing you on the horizontal axis is the percentage of Black children who were removed from home, and the blue line is the percentage of white children who were removed from home. The vertical red line is when the tool was introduced. What you can see is prior to the introduction of the tool, Black children, when they were referred and screened in, they were much more likely to be removed than white children. However, the introduction of the tool led to, we believe, a complete dissipation of the gap in removals between Black and white children. So that was one of the crucial findings of that paper, is that by using quasi-experimental methods, we were able to show that the introduction of these sorts of tools support reduce disparities in decision-making. Another study completed by an independent research group of one of our tools in Colorado was a randomized control trial. So that's usually considered the gold standard. They looked at 1.5 years and randomized who would get the tool, which of the screeners would get the tool and which wouldn't. The scores again were highly predictive of fatalities. And what their key finding is that it reduced hospitalization by 32% and reduced the black-white investigation gap by 50%. So what we find is that those Black children who were scored at below median risk were, after having the score shown, more likely to be screened out. High-risk Black children didn't change in their screening decision. The results actually are supported by other findings of our tools that are done by other research groups. So overall, most of our projects are finding a reduction in racial disparities. We don't have a good understanding yet of why that might be, but my belief is that data may be offsetting the priors, the beliefs of workers, and supporting them in being less investigations of Black and Hispanic children.
Jora Rema. Our third and final speaker in this health and safety block is Wits Ambassador Paolo Petrone, who is an associate research professor and head of the biomedical data science team at the Barcelona Institute for Global Health. Her central question is, can AI today see beyond the expert clinical eye? Espero que les guste. After Paula's talk, we'll see her together with Rima and Sparkle in a fireside chat in which they take a deeper dive into data science and health.
So hello everyone, it's a real honor for me to be presenting here at the Wits Global Conference. My name is Paola Petrone, and throughout this talk I'd love to share with you my experience with deep learning, which has been quite transformative, I must say, how I transitioned from being an AI agnostic to becoming an optimistic believer in the power of AI to enable us to see beyond the obvious, which is especially relevant for healthcare. So let me introduce myself as a physicist by training and a biomedical data scientist by trade. In my lab, we develop data science applications that aim to improve the health of people. We work with different data modalities and develop algorithms for the early diagnosis of various conditions. For example, we would like to understand why we age and how to reverse aging, which is the holy grail of rejuvenating medicine. We would like to identify who is at risk of contracting infections like COVID, malaria, or Chagas, or identifying people with cancer, tuberculosis, or liver disease. In the last year, our lab initiated a very exciting collaboration with startup company Newborn Solutions. The challenge in this case is the early detection of meningitis in babies. Meningitis is an excruciating condition prevalent in developing countries. Meningitis is caused by inflammation in the brain due to bacterial or viral infection. The mortality rate in newborns with meningitis is quite high. It ranges from 5 to 20%, and it heavily depends on early detection. So diagnosing early saves a lot of lives. It is important to understand that the standard diagnostic procedure is a lumbar puncture used for counting white blood cells in the cerebrospinal fluid, which, as you can see here in the picture, is a quite invasive procedure. As a parent, I wouldn't let a doctor perform a lumbar puncture in my baby unless it's critical. So this is not an ideal procedure for meningitis screening. So Newborn Solutions has now developed an alternative method. They have created a non-invasive and portable ultrasound device. So the great thing about this device is that it is small and easy to handle, and it can be taken to remote, low-income regions with a high prevalence of meningitis, like, for example, Sub-Saharan Africa. So see this red area right here? That's the baby's fontanelle, a soft spot on the baby's little head. So when we perform an ultrasound, we scan this fontanelle using a completely safe and non-invasive ultrasound method. This technology gives us high-resolution images of the cerebrospinal fluid, just like the ones I'm showing here. So now, the analysis of these images is the real challenge. In one column, we have images of healthy babies with no inflammation and no white blood cells. And in the other column, we have images of babies with meningitis with a very high white blood cell count. But here's the thing, even for a trained human eye, telling the difference between these two is nearly impossible. And this is because our eyes and our brains are not prepared, are not able to perceive, let alone count, these white blood cells. However, for a trained convolutional network, this task is totally possible. Now, using a deep learning architecture like the one we have here, which is a ResNet 50 pre-trained on ImageNet, we can achieve almost perfect accuracy in identifying babies with meningitis based on their Fontenelle ultrasound images. So our results are very accurate. We were able to correctly classify 16 out of 17 babies. And this is so promising that we are now further validating these methods on larger cohorts. So now we can see how the network classifies meningitis on the left and controls on the right. Interestingly, there is an increasing white blood cell concentration in the different images as you go down, which even the expert eye would miss. Now the big question is, how does the network do it? How does it manage to distinguish between these two cases? What are the particular factors, patterns, or textures in the image that enables the CNN to make this prediction, which is quite tricky for us humans to pick up? So this is the right moment to talk about the explainability and transparency of the algorithms. So not long ago, AI algorithms, especially deep learning, were like black boxes. So you feed them data and they give us predictions, but we didn't really know how they reached those conclusions. But times have changed, and today regulatory policies, patients, doctors, and also our common sense are all calling for transparency in AI. People want to understand how AI works and to trust it better. So this is when a series of algorithms called Explainable AI, or XI, come into play. These algorithms applied to the neural networks show us which patterns are responsible for the prediction. For instance, there is this cool algorithm called GradCam that explains which pixels in an image are mostly used by the neural network when it's trying to tell apart dogs from cats. So going back to the ultrasound case, using XI and GradCam allows us to identify certain patterns or pixels that indicate areas related to white blood cells. For the meningitis case, we definitely see these big red blobs that are associated with the white blood cells. So more blobs, higher cell counts, more inflammation, indicating the condition is more severe. However, if we try to explain the images of the healthy babies, you see much less of these blobs, or you see none at all, indicating that these babies have no infection. In the past, I used to believe that before I started any medical image analysis project, for it to be successful, I had to rely on the ground truth given by the expert eye of the doctor. So for me, the take-home message with this project, and other projects that follow this one, is that deep learning can see patterns in images that remain unnoticed by the human eye. So to conclude, I really love that famous quote by Saint-Exupéry in The Little Prince. Many times, what's really important is invisible to the human eye. And that's really where explainable AI steps in, not to replace or displace the doctors, but to empower them to see beyond, complementing and enhancing their unique human capabilities, such as intuition, empathy, and experience. So we refer to this combination as augmented intelligence, where AI and human intelligence work together to solve very difficult challenges. In particular, in healthcare, I believe this synergy will help doctors make better decisions, ultimately leading to better quality of life. So with that, I would love to thank my team at IS Global, and particularly Hassan Sial for his work on this project. I'd love to thank our partners at Newborn Solutions, and of course, I thank you all for listening.
Well, Paula and Sparkle and Rima, thank you so much for joining us. Wonderful talks, and I'm really happy to have the chance to sit down and dive a little bit deeper in your topics, because there's a lot of commonalities also across the talk. So this will be a lot of fun. And I also wanted to say this is a truly international panel. So we have Rima joining us from New Zealand. We have Paula in Spain. And then Sparkle and I are in California and Oregon, so the west coast of the United States. So very global panel here. Let me just start by asking you a question about how you got to where you are.
Absolutely. Thanks, Margot, for having me, and it's amazing to be alongside these other amazing women. So where I got my start, actually, I'm very non-traditional. I oftentimes when I talk about data science, the folks ask me, how did you transition so many times? I tell them I'm pretty much like a real world neural net. It's not linear at all. In that I started off as a chemical engineer, and at that time, the goal was always to go into oil and gas from chemical engineering or some manufacturing role, which I did. But I knew deep down inside I wanted to work in the healthcare space. So as an undergrad, I actually seeked out summer internships. Instead of going and working for an oil and gas company, I did an internship in one of my professor's lab. And at that time, she was trying to look at ways that you can develop drugs that target solid tumors within the body using the principles of chemical engineering, so fluid mechanics. So how do we evade, for example, the immune system? How do we use the principles of Navier-Stokes and flow and understanding how you can concentration gradients can get into the tumor, which is fundamental. And at that time, it was biomedical engineering was new. So I was like, I don't want to just jump into biomedical engineering at the time. So I finished off chemical engineering, went into Procter & Gamble making Old Spice and Gillette deodorants. And I knew that that was not part of what I wanted to do. So I gave myself a 2-year window and said, if I fell in love with this, I will actually, if I am passionate about doing a PhD, at 2 years, I'll make that decision to transition back. And I did, focusing on biomedical engineering. And again, data science wasn't a thing at that time when I went back from a PhD in 2010. So I actually transitioned and started taking my PhD work and just doing data science projects on the weekend at home. And that was sort of the evolution. And then I had a mentor that pushed me to start putting it out in the public domain via blogs. And I started blogging. And I often tell people that was a way that it helped me sort of put myself out there. And even if it's not great, if I go back and look at the history of when I started doing the blogging to now, it's changed, it's evolved over time. So I see my growth in real time in the public sphere. And literally, that's how I got my start in data science. It was not traditional at all. I sort of evolved and continued down the path knowing that I wanted to be in health, but what aspect of it and what questions I wanted to answer is what drove me.
What about you, Rima?
Yeah, I'm non-traditional as well. I still don't quite know if I found my niche, but I love what I do. I love what I'm doing right now. I started in theory, in economic theory, which is as far as you can get from data science. I just, I loved math, so I loved the theory. But after a while, I realized that I was really frustrated by the fact that I wasn't making a difference to the things I cared about, which was social sort of challenges. So then I moved into data. I did some work I had a fellowship in the US. I met some people from the NHS in the UK. I went to the UK and worked with them on one of their first hospital admission models, which is a very simple model, but that was 2007. So it was pretty early to be deploying these models. And then I came back to New Zealand and I actually deployed one for all the hospitals in Auckland. I think no one's redone that work. So I realized I was pretty good at getting stuff done, which is always something I really actually liked. And so after that, I started in health. And then I always say to people, one day I looked at my hospital data and realized the median age of my data set was 70. And suddenly I thought, maybe this is not I'm much more passionate about children, and the healthcare system is more and more serving older and older people. And so then I started working with a really close collaborator now in child protection and child abuse and neglect. And I said to myself, let me, make this into my area that I want to make a difference in. And subsequently, I moved into homelessness and mental health. So I very much work on issues that are affecting probably 1 in 20 of our most vulnerable families in a community, and working with how data science can work in the front line. And I just love that work. And I'll keep doing it until, they have to wheel me out.
Thanks. What about you, Paula? Have you always known that you would want to end up where you are now?
No, actually, I think also it was like a long and winding road, as my fellow panelists. I think it's mainly because when we had the choice, there was no such thing as data science, right? So we just went through life and finding our way. So I'm a physicist by training, and then I became a biophysicist with my PhD. And then I discovered life sciences at that time, and probably because I wanted to know how things work. But then I was fascinated about how life works and why are we here, and actually what makes us sick and what makes us healthy was one of the things I was wondering. And I did a lot of simulation. And after a while, when you do simulation, you wonder also whether your models are correct. And that's when I realized and I made the decision I wanted to work with real world data and real world data from patients to understand what makes them sick. And that's, I think, how I came to study a lot of chemistry and biology and medicine. So I think it's at some point I became a generalist. So that means probably being an expert at not being an expert, because then you get a lot of new projects and then you have to actually try to find your way through them. So exciting. And I was mainly almost all my career in the industry, and now I'm a professor in academia. So I think this is something new for me.
Well, one thing that you have all mentioned, either in your talk or just now, is that when you started your career, data science and data science algorithm hadn't really penetrated your sectors or the healthcare sectors that much. But now when you look around, it's everywhere. So there's been very fast adoption of data science techniques and algorithms in the healthcare industry. What has surprised you the most about this? I mean, I find the whole thing surprising. The speed and the acceleration that we're seeing is mind-boggling at times. How fast developments are made and how quickly people are to adopt and use it. But what has surprised you the most?
So maybe for me, I've discussed in class when I teach students about AI, we used to talk about narrow AI or limited AI, but in the last 2-3 years, we started to witness this revolution about large language models and ChatGPT and these algorithms that perform many tasks at the same time, and they outperform some of our human capabilities as well. And for me, this is surprising how we're moving to this general intelligence, and we may get there in the next years, which I thought I would never witness in my life.
I think for me, even though we are making the advances, the biggest challenge is how far behind we are with getting the data curated, particularly in the US. It's disparate, it's not standardized. And I think a lot of the challenges you will have is how do you harmonize those data sets to generate insights? So from my lens, we will develop something that can work, but then the question becomes, can it work outside of what I've developed? And because each data set, each hospital system is quite different. Each platform that collects data sets within a hospital can vary even within that hospital. So how much work has to be done on the preliminary front? So much of it is focused on the algorithms. Very little of it as a data scientist, I've started going further back up, is focused on why don't we spend the time to get the right infrastructure in place to get these data sets to a state where we can build tools, not say to solve every single problem or generalize to everything, but to at least get to a point where we could deploy some of these algorithms that are performing well and can make a difference.
I think I'll push back on the question. I actually don't think if you look at frontline clinical decision making in your median healthcare system, I'm not talking about your coastal East Coast systems. I'm talking about go to a Midwestern small town clinical center and ask yourself how much of this technology is penetrating into improving outcomes for that patient population, I actually don't think it's not touching the sides, in my humble opinion. And I think it's partly because a lot of the technological advancements are not being, there's no single kind of industry that is motivated to take those tools and put them into the hands in a way that both patients and clinicians find acceptable. I feel like there's just not the same work that is being done, say, on the pharmaceutical sides. Like, we have thousands of pharmaceutical reps around the country who knock on the doors of clinicians and tell them about the latest findings, tell them about the pill, the side effects, and yes, you can adopt it. We don't have that for AI. We don't have anyone who's proselytizing the technology for standard frontline clinicians who did their medical training when they didn't have access to these sorts of tools. So my feeling is, I don't think we're going to see any of the impact for median patient population until someone solves that problem.
Maybe one thing to add as a challenge along these lines is the lack of translational the lack of translation from the academic setting to the clinic. Actually, a lot of people talk about AI in the hospital, medical AI, but you, at least here in Europe, you get to see very little AI in the hospital, side by side with the doctor. And that's, if we ask ourselves why there is no translation, I came to think that one of the reasons is that there's still a gap about who is going to pay for it. Who is going to pay for the AI in the clinic? So I think the AI is made by humans, and there is human everywhere in the AI. So there is human in the collection of data, in the algorithm development, in the interpretation of the data. So basically, maybe people, it's not they don't trust the tech itself, but the minds behind the tech. So I think there will be a leap when we can explain the people and educate the citizen on why we're using AI, which are the benefits, and that they see that there is a human in the loop, and that there is a human in the loop accompanying the AI in the decision making. There is not just an AI by itself, but there is an AI assisting the doctor.
Absolutely agree. I think a lot of in my space where randomized clinical trials are the gold standard, it's a lot difficult to come in and say, I'm just going to have an AI tool in the case of imaging, right? To grade an image, which is a key endpoint. You're using using AI to replace a human, which is the gold standard from a clinical trial perspective, to grade an image. So the question becomes, like, how do we make sure that the clinicians are involved and understand? And that's the piece, exactly what Paul is saying, is the education piece, that you're not going to be replaced. It's more of a way to augment and reduce the inter and intra variability that you get from these manual processes and increase productivity. But again, sometimes when you lay it down as productivity increase, it seems like, are you going to move my job? No, it gives you an opportunity to focus on other parts of the disease landscape that is equally important. By increasing, reliability on what you're doing, so you could focus on developing in other areas. So it's just that language around how we involve. And one of the things I try to be mindful of is making sure that those folks are involved in the design process, so their feedback is involved. Back to what Rima was mentioning, starting with the end and going backwards, I think has sort of gotten me a little bit more traction with some of this stuff in my space, where it's even more like, questioned a lot more.
Maybe I think one of the turning points that we will see in the next years is about the ChatGPT type of models, the large language models, when we see patients directly and doctors interacting with the technology and asking questions about their health. And very, very, very soon, we will have also the models asking us questions about how we feel. So then there may be a point where we will not know whether we are interacting with a computer or with a telemedicine doctor. So I see that may be a huge challenge also for the trust issue, right? So we as patients, we will have the right to know whether we are interacting with a computer or we are interacting with a real person. So I don't know what you guys think, but I think in the future, these will be the next conversations that will be on the table.
I mean, I don't know that people are as concerned as media make it out to us. I was on a national committee and we had to have conversations across the whole country to understand people's attitudes to data sharing and some of this technology. And we found that it was really a trade-off between what the value for them they saw it as and the transparency with which you were going to do it. People didn't have as much, at least when we spoke to people in very ordinary settings, you know, in your golf clubs and we didn't see the same level of concerns that people seem to portray. I think there's been a kind of sort of I call it a fetishization of AI. It's just an easy thing for people to get the clicks and to get the front page news. And I don't think that conversation as it's happening in the elite circles reflects correctly the conversations about that technology that's happening in kind of everyday middle New Zealand or middle Australia or middle US. So I don't feel as concerned about the community because as I've been working in child abuse and neglect, which is a very challenging area, we basically explained to the community that we've been trying all kinds of things and we haven't moved the dial. And that communities are very open to giving us what we in our group call social license to explore new ways of trying to move the dial because they see the value of moving the dial on something so challenging. So I think that social license piece is not as concerning as if you were to read newspaper articles.
So good to hear this. And I have this other perspective. So it's incredible how fast time flies when you're talking, and we're almost done. But I wanted to ask you one last question. I'm curious to see what you say. And this is a question I've asked other panels as well. So if you could steer the world in a particular direction, so you would be the boss, and you could tell people what to do, what would be the first thing you would do in this space?
I guess I would say stop the narrative that it's going to replace people and start the narrative that is going to complement people in their existing roles, because I actually never think that we're going to replace people. People are too cunning. They're never going to be replaced. So now we're going to have the conversation that it's going to complement and augment people in their jobs.
So for me, I think it would be important that we think more and we promote diversity in the algorithms, in the data sets, in the way we think about AI. I think we should promote, especially in healthcare, that AI applied to healthcare is equitable for everyone.
Absolutely. I totally agree with my fellow panelists. I think there's a lot of sensationalization of AI, and it's not going to replace it, will augment. You can't replace a physician in terms of decision-making with an AI algorithm, but you can augment it, their decision-making process. And from the perspective of teams, you do have to have diverse teams making these type of tools so that you can meet folks where they are.
Well, thank you very much again, all of you, for joining us, for taking a little bit of a deeper dive and lifting the veil a little bit more about what's going on in your minds and in your fields. I wish you great success with the rest of your career, and I hope you all enjoyed this panel. Paula, Sparkle, and Rima, thanks. We have many Witsers working in healthcare, like our colleagues Kat Steele and Megan Ebers. Kat is a professor of mechanical engineering at the University of Washington and the director of the Amplifying Movement and Performance Lab. Megan worked with Kat on her PhD and is now a postdoc. Enjoy this 5-minute video about their work, supporting mobility from walking to wheeling.
For our work, we're really working to support mobility in all its forms for individuals with disabilities. We love working with our participants. We see them as co-designers and creators in our process as they're helping us understand how technology can support their mobility in daily life. And so in particular, we work with kids and adults with cerebral palsy and stroke survivors to help them understand how their body is moving after injury and how our technology can best support them. And so as I've progressed in my career, I've become much more interested in supporting mobility in all of its forms, from walking to wheeling. And wearable sensors and data science are a big component in helping us understand this and to eliminate some of the bias and barriers that currently impact an individual's mobility. And oftentimes our traditional healthcare mechanisms to support those don't actually get to what they need in daily life: moving, exploring, and for kids, playing.
How do you make the music play? Great job.
As we try to figure out how to leverage all this data to support mobility, one of our big challenges has been figuring out how do we optimize our assistive technology and other techniques to best support each individual's mobility. One of our techniques that we've often used to make sense of all this data is to normalize it to population-based averages. However, in doing this, we often were ignoring the reality that what is optimal or best for one individual is highly unlikely not the best for another. This is something that we call the normalcy fallacy, or basing our decisions or evaluations on normative assumptions of a population-based average that may not be appropriate for the group that we're working with, such as children with cerebral palsy. Now, one of the techniques that we've been exploring for the normalcy fallacy is something that we call discrepancy modeling. We have to remember that every brain injury is unique, and that means each individual moves and participates in daily life in a different manner. And so Megan's been developing these discrepancy modeling frameworks that leverage data science and machine learning, along with our physics-based modeling and experimental analyses.
Discrepancy modeling is a new machine learning technique that myself and my collaborators developed originally in applied mathematics to help resolve the mismatch between the models that we build and the measurements we get from reality. Discrepancy modeling also allows us to investigate and probe what and how much data we need to be able to capture a discrepancy, and if that looks different for different people.
We often call it an error, but it's not an error. It just is the fact that our normative set is not appropriate for this individual.
I think the outcomes of some of this work with discrepancy modeling will allow us to better understand how an individual might respond to assistive devices or clinical interventions. Hopefully it can allow us to inform clinical treatments or aid exoskeleton designers to optimize design parameters to best help an individual.
And so as an example, when an individual learns to use this exoskeleton, it can feel clunky and odd at first. But also on the backside, these are powered ankle exoskeletons, so they're providing torque and force to the body. And while some methods can be used to try to approach a non-disabled walking pattern, that likely isn't optimal for this individual. And so understanding how an individual responds with discrepancy modeling, plugging that information in to a method like human-in-the-loop optimization, where we can then help them optimize and discover the best movement pattern for them, represents the exciting frontiers that we find for this melding of data science with biomechanics to support mobility. And it's been really fun seeing a lot of the kids that we work with go from being young kids in our lab to starting high school. And so we've been trying to challenge ourselves as engineers to not just address the human body and assistive technology, but spend as much time also understanding how can we leverage data science. That's really been a lesson from the individuals that we've worked with over the years. We can create as much technology as we want, but unless we dismantle some of these environmental and societal barriers, we're not going to be able to support mobility in all its forms.
I look forward to our fourth and final thematic block of this conference. 3 10-minute talks on leadership. And after, I sit down with the speakers again to dive a little deeper. Later, we are joined by Melinda Leckham, Ruth Shaber, and Patience Marian-Ball. We start with a talk by Wits Ambassador Lama Moussaoui, who joins us from Lebanon. Lama is a tenured professor of management science at the American University of Beirut. In her talk, she examines the status of women in leadership roles in the Middle East and North Africa region, and she does that through the lens of two phenomena, the bursting pipeline and the glass cliff.
Hello, everyone. It's a great pleasure to be presenting today at the Wits Worldwide event. I would like to thank the organizers of this event and the Executive Director of Wits Worldwide, Professor Margot, for this great opportunity. In this talk, I examine the status of women in leadership roles in the Middle East and North Africa region, focusing particularly on the bursting pipelines and the glass cliffs. Women in the MENA region are drastically underrepresented in the workplace. This is evident by the fact that the MENA region has the lowest female labor force participation rate in the world, at about 18%, compared with 47% globally. The chart to the right-hand side shows the distribution of the female labor force participation across countries in the MENA region, with Algeria and Iraq scoring the lowest at about 12%. Here, I present some shocking facts about women in leadership. Some of the facts and the findings in this presentation are based on research we did at the Center for Women in Business and Leadership, which is housed in the School of Business at the American University of Beirut and funded by the MAPI office at the United States State Department. The percentage of women in senior decision-making roles in the Gulf states is 3%, extremely low. 15% of the companies in the region have anti-discrimination policies versus 42% globally. And this is a major barrier towards having more women in the workforce and eventually in leadership roles. The female participation in STEM workforce is 10%. It's the lowest in the world compared to an average of 29% globally. Women in decision-making roles are about 16%. The STEM sector has the lowest women in decision-making roles at about 12%. Looking at women on boards, we can see that the Middle East has the lowest score at about 3%, the representation of women on board, versus Northern Europe at about 37.6% due to mandates probably over there to have more women on boards. The US and Canada have about 26.5% representation of women on boards. Women organizations gain from having more women in senior leadership positions. Research has shown that this contributes, having more women in leadership positions contribute to higher profitability, improved shareholder valuation, better performance, higher return on equity, less fraud and corruption. And this is because women offer diversity of skills and perspective, which results in distinct problem solving. We examine now the bursting pipeline phenomenon. More and more women in the Middle East are equipped with knowledge, skills, and expertise, but they are unable to secure employment. In the MENA region, for example, women graduate from STEM fields at equal or higher rates than in developing countries, reaching 57% in some MENA countries. This is the highest in the world, versus 31% for OECD countries. However, the issue is that women's participation in STEM professions is very low. It is, in fact, the lowest in the world at about 10% versus a global rate of 29%. In contrast to the leaking pipeline, common in Europe and in North America, the pipeline in the MENA region is experiencing an ever-increasing pressure, which research studies refer to as the bursting pipeline. Why is this the case? Because women face many barriers and disadvantages that we will talk about in a moment that preclude them from accessing the formal employment, let alone leadership positions. This effect is exacerbated by the youth bulge, which has a destabilizing effect on the Arab MENA region, and the youth unemployment in the MENA being the highest, among the highest in the world, estimated at 25%. Therefore, female youth are the most disadvantaged, complicating gender dynamics in the MENA and resulting in a very low participation rate in the workforce and in leadership positions. Some of the challenges that women face along their career: women are not applying enough to jobs that match their education. Even if they apply, informality in recruitment policies results in more men being hired. As they grow in their careers, the retention policies are insufficient and they are forced to seek help from outside help to maintain work-life balance. The absence of formal sexual harassment and discrimination policies force women to leave. They are given ample development opportunity, but this does not translate into leadership positions. So we end up with only a few women in leadership positions or decision-making roles. There are other organizational barriers and sociocultural barriers. Organizational barriers include lack of transparency, nepotism, connections, unfair promotion process, lack of senior positions, which limit the women's promotion and access to leadership roles. More training and development opportunities are offered to men. Women are discriminated against due to marriage and having children. If we look at the sociocultural barriers, this includes conflict and instability in the region, inflexibility to travel, long working hours, lack of options for childcare and family, household care, childcare, social stigmas, and discriminatory practices that women face, gender stereotypes, lack of mentors, and lack of networking. Other phenomena include glass walls, which refer to the fact that women take on managerial roles that are supportive in nature, like R&D, like HR versus men, taking on more key positions, managerial roles such as R&D or finance or operations, which paves the way for men taking on leadership positions. Glass ceiling is a metaphor for an invisible barrier preventing women from rising to senior positions, even though they have the skills and expertise. Glass cliff, which refers to the tendency for women to be appointed to leadership positions in times of crisis. Women are elevated to positions of power when things go poor, and they face a greater risk to fall off the cliff. Status quo bias is the main reason behind that. As long as a company performs well, there's no perceived need to change, resulting in a bias towards maintaining the status quo and having more men in leadership positions. However, when things go poorly or in times of crisis, appointing a female leader signals change. And this is more pronounced in contexts in which male leadership is the norm. What can women do to avoid a class cliff? They can consider the basics of the role, the responsibilities, the compensation. They can look more at the company's culture, examine the gender composition of the company's executive team, talk with previous leaders and about their experiences, check if there are mentors that can help women navigate tough decisions in times of crisis. Leaders can make sure that women have access to the right resources, they can assemble teams to support them, and are offered training and development opportunities. Some of the strategies that in order to make sure more women rise to the top, the role of the board and senior leadership is very important. Senior leadership should take actions and set targets to overcome the barriers women face in accessing leadership roles. For example, implementing company-wide gender diversity, making sure there's a gender-balanced leadership, building a strong, inclusive corporate governance framework. The participation of senior leaders in the promotion process sets the tone from the top and reinforces inclusive behaviors that everyone should demonstrate. So the participation, engagement, accountability of senior leader is also very important. Senior leaders should actively promote the importance of development for women and can act as sponsors, mentors, advocates for the development of women and provide more opportunities for women to rise to the top. It's important to build a pipeline of female talent, recruiting and retaining female talent to create an internal pool of competent female employees that are up for promotion. Building a network of female mentors and role models for women. It's important to also report on international criteria concerning women's inclusion, such as ESG, SDG, and WEPS. implementation of gender-inclusive policies and practices, such as implementing anti-harassment and anti-discrimination policies. The role of government and gender machineries in the MENA region is also important through ministries, councils, and committees to launch legal frameworks to work towards women's inclusion, such as EEO, Equal Employment Opportunities, and important to highlight local success stories.
Shukran Lama. Our next speaker is Melinda Leckham. She joins us from upstate New York. Melinda manages a team focused on developing machine learning models to prevent abuse and automate detection of abuse on the LinkedIn platform. She talks to us about navigating the trenches, managerial challenges in machine learning for anti-abuse.
Hi, I'm Melinda, and today I'd like to give a glimpse into the unique managerial challenges in machine learning for anti-abuse. Before I dive into that, a brief background about myself. I really enjoy learning about the journey people take towards their current role, and I hope you do too. I was born and raised in India and did my bachelor's in electrical engineering from the Indian Institute of Technology, Madras. I was one of 2 girls in a class of 60, or 5 out of 120 if you were to count the co-term folks. Now, why do I bring it up? I did not think much of it back then, but I do believe that the cultural forces contributed to this extreme gender imbalance, and it was not productive for the student population. I, for one, am thankful for all the people in my life who nurtured my interest in math and science, and hope conferences like these do the same for more women. I finished my undergrad studies during the recession of 2008 and decided my time was better spent in higher studies and applied for a master's in computational math because it was an interdisciplinary program with the flexibility to choose from a wide variety of application areas. And I continued on to get a PhD in the same field. At some point during my PhD, data science as a field took off, and in my quest to find the right fit, I did a fellowship with Insight. It was a great program where 40 different teams came to you in the first 4 weeks and told you what they do and what they were hiring for. This is when I interviewed with the anti-abuse AI team at LinkedIn. I worked with the team for close to 4 years before switching to Twitter and moving back to LinkedIn to manage a sub-team of anti-abuse AI, which at this point had become a much bigger team. All right, so that was my professional journey to where I am today. So, what does my team do? We build models to prevent and detect abuse on the platform. Now, what does abuse look like? It can take the form of phishing messages to steal your password, account numbers, social security numbers, etc. It can look like posting spammy content, for example, selling fake Ray-Ban glasses, and we don't want that on LinkedIn. It can look like inauthentic engagement. You can see services offering to artificially inflate the popularity of your account by following it, and the content you post by liking it. Abuse can also look like posting fraud jobs which aren't real. The motivation of all abuse inadvertently is money. In order for the abusers to make profit, they need to scale the abuse. One way to scale the abuse is to use fake accounts. Accounts whose identity does not match with the real person. And compromised accounts, where the attacker has access to an account that is not their own. My team focuses on building models that prevent fake account creation and account compromises at scale. Before I get into the managerial challenges, I'd like to spend a few minutes talking about the technical challenges that lead to the managerial ones. The first, noisy labels. I presume in most fields, it is hard to find clean labels. I think it is particularly hard in our field. First, you need to be clear on what a fake account is and back it up with policy. Assuming you have resources for manual reviews, you need to have tools in order to be able to label a fake account accurately. Even if you have the tools, there is some variance between manual reviewers that you need to account for. Next, we need to work in an adversarial space. More often than not, you're dealing with highly motivated actors who adapt and evolve to evade the defenses we put in. Next, we need our models to operate at high precision and hopefully high enough recall. High precision ensures that we are not impacting good users and they have the best possible experience on the platform. Now, the last one, this can be a talk in itself, but designing metrics to measure model performance is challenging due to some of the reasons I alluded to earlier, which are noisy labels and the fact that adversaries adapt. Now, these technical challenges contribute to some managerial challenges unique to this problem space. Now, all the other people management challenges still exist, and I continue to learn every day. Now that I've said that, let's get to the first one, negotiations and alignments with partner teams. The work that my team does impacts the user experience on the platform. Trust growth trade-off is as intrinsic as precision recall trade-off that you learn in traditional machine learning. To be able to deploy models in production, we need to come up with a set of principles that all teams can be aligned on. And it can be really tricky given the far from perfect data we work with. So how do we do it? We come up with the best possible proxies and iterate on them with every lesson learned from a new model deployment. Iteration is the name of the game. Next up, dependency management in the face of rapidly changing priorities. Our projects typically have dependencies with other infrastructure and data science teams. We can come up with a plan for the quarter, but it can change based on what our adversaries do. And planning can quickly become unmanageable in some scenarios. What I found to help is having close relationships with partner teams so you can communicate about changing priorities if they do change, and having really good on-call practices so that the plan for the quarter can stay as unaffected by the adversary behavior as possible. Next up is communicating impact. Given the challenges in model performance measurement, we are almost always looking for better ways to communicate impact. I found that having the team involved in designing the metrics helps. So does monitoring all the relevant data that can help stitch together a coherent narrative. Last but not the least, avoiding burnout. Our adversaries keep work interesting, perhaps too interesting at times, and it is easy to fall into the trap of working unsustainable hours. I think what helps here is clear communication of prioritization and expectations from the leaders. And personally, the realization that you can improve but cannot solve all the abuse problems completely. Also, having something that is not work-related that you really enjoy helps. For me, it is my almost 1-year-old baby and my bicycle. It is hard to be stressed out with both of them. On that note, I'll end this talk and hope you found something that resonated with you. I look forward to seeing you all in the panel.
Thanks much, Melinda. The final talk in this block on leadership will be given by two speakers. Ruth Shaber and Patience Marin-Ball recently co-wrote the wonderful book, The XX Edge, Unlocking Higher Returns and Lower Risks. The book shows the strong and positive impacts women make in leadership roles. Ruth is the founder and president of the Tara Health Foundation, a philanthropic investment group that promotes opportunities and well-being for women. Patience is founder and CEO of the Women of the World Endowment, which invests its capital in and through women for deep impact. Join us for the next 10 minutes to hear more about the XX Edge, and then stay to listen to a panel discussion with all 4 speakers in this block.
Patience, I'm so excited to be here with you today to talk about our book, The XX Edge, Unlocking Higher Returns and Lower Risk. Why did you want to write this book?
Thank you so much, Ruth. It's fun to be back recording something again. So as you know, my focus on investing in and through gender diverse teams started in 2008 after the subprime financial crisis, when I was working as a principal investment officer in the financial markets group at the International Finance Corporation. I then really focused on building the business case for investing in women globally. But as you know, the data has gotten so much stronger compared to back in 2008. And so writing this book was really to bring the data into focus, especially for men in financial markets. Why did you want to write this book with me?
Well, my experience at the Tara Health Foundation, where we have 100% of an alignment in our investment portfolio around gender finance, we were seeing that we were outperforming the market, not in spite of being gender focused, but because we were gender focused. And the evidence was so compelling across all asset classes that when women are at the financial decision-making tables, you're going to have a stronger portfolio and less risk. And we knew that this was information that had to get out, and particularly that we had to make sure that men had the chance to learn, that women were living this, and particularly women in the finance industry knew this information really well, but that we needed to find a compelling way to share it with men. So that's why we wrote the book. But why don't you tell us a little bit about the evidence that we uncovered?
Yeah, so you know that in the early days when we're doing the research, we're afraid that we were going to have to cherry pick the data, but what we found was that the evidence is really clear across all asset classes that when you bring women into financial decision making rooms, that outcomes are better, all the way to new companies with at least one female founder. They outperform their peers by 63% percentage points. McKinsey in 2018 came out with a study called Delivering Through Diversity. And in that report, they also concluded that gender diverse teams were 21% more likely to deliver outperformance in profitability relative to peers. Even in the hardcore finance area of hedge funds, we know that women-run hedge funds outperform the average of larger hedge funds by a margin of about 6%. And this is a study that was done over a 6.5-year period. But it's one thing for us to say this is the data. One of the things that we wanted to do in this book was to isolate what it is exactly, what is the edge that women bring to the decision-making room that results in some of this outperformance. Could you share a little bit of what we found out, Ruth?
Absolutely. So certainly there's just a question of talent, that if women are representing a very small fraction of whether it's venture capitalists or CEOs or board directors, that if you bring more women into those positions, that you're going to get more talent. So there's just that basic understanding that you need to have a better pool of talent in the room. But also we know that women tend to be closer to the problems that need to be solved. And so if you are trying to come up with solutions for whether it's healthcare or education or the care economy or climate change, that women are the ones who are most impacted. So they're going to be the ones who are more likely to bring innovative solutions to the table. We also know that women tend to be more networked and have a more collaborative leadership style, which is also an important factor to bring into these rooms. And finally, this is a much more of an argument for diversity in general. When everybody sitting around the table making a decision looks exactly the same, they're going to miss stuff. They're going to not see around corners. They're going to not have the solutions that are often based on people's lived experiences. So basically, just just diversifying a team is an essential part of having excellent financial performance. And this isn't just for gender diversity, but goes for racial diversity and any type of diversity. So in the book, Patience, we have some great examples of how this plays out. Can you tell us one of your favorites?
Absolutely. So one of my favorites is centered on Portugal, which provides an excellent example of applying the female characteristics of one of the characteristics that you mentioned, which is this collaborative leadership, but applying it to a nation's technological ambitions. So over the last 15 years, Portugal has been transforming itself from a technological standpoint with many women in leadership roles. So their marquee program is called the Simplex program. And this has been a citizen-centric, multi-year bureaucratization of the government, based on the belief that government should be agile, public services should be accessible, they should be seamless, efficient, and regulation should be minimal. Simplex has essentially led to over 1,500 changes to improve the design and delivery of public services so that people can have a one-stop online portal to sign up for services that they need, and citizen kiosks that are located throughout the country. But the kicker, Ruth, is that this program has worked to really spur economic growth as more global companies, technology companies, have moved their operations to Portugal. And remote workforces have moved to Portugal to enjoy the incredible weather, but also this technological base. I know that you also have a favorite story, Ruth. Do you want to tell yours?
One of my favorites came out of India. So young women in New Delhi who were outraged by gender violence that was going on in their communities were able to harness technology that we all take for granted now, which is based in our GPS tracking systems and our, whether it's, the ability to download where there's an accident or a traffic stop or some other incident as you're driving that everybody can then take advantage of and redirect their routes. What they did is they used that technology to be able to track in real time where there was violence happening, whether there were incidents that they wanted to be able to share with their community, or there was a street light that was burnt out that was making it riskier for people walking home from work, or an abandoned building, or gangs were hanging out. And what they found very quickly is that everybody was safer, not just the women in the community. And this was such a successful technology, it's called Safety Pin, that the governments got involved. It's been expanded to over 16 countries and 75 cities internationally. And I think this is a great example of how the people who are closest to the problems were in the position to be innovative and bring the best solutions to the table. And so these are some great examples, and the book is filled with many, many more that outline why these decisions are better when you have diverse teams.
Yeah, and inclusive solution building actually does build, much more resilient and lasting and inclusive solutions as well. And so to the talented people who will be listening to this recording, one of the things that you and I wanted to do was to really bring forth these stories to show that we can change the paradigm of women being beneficiaries to women being central to decision making, to problem solving. And as we wrap up this conversation, I just want to invite you to talk about what the folks who are listening to this can do.
First of all, we hope that people of all genders will buy the book and read the book. We really intended it for everybody, not just for people who describe themselves as women. And so that's number one. Number two is to appreciate how important it is to have diversity in your organizations, whether you're in business or in finance or voting for people to represent you at the school board or state or national level. That diversity actually is an extremely powerful tool for better solutions and more resilient economies. So that's another thing that you can do. And if you're interested in learning more about the book and about these programs that we're launching as based on the book, I hope you'll get in touch with us. Here's a QR code that you can download. You can email Robin Russell at the Tara Health Foundation and learn more about the work that we're doing.
Hey, Lama and Ruth and Melinda, it's just wonderful to have the opportunity to talk to you a little bit more and dive a little deeper after your 3 wonderful talks. So thanks so much for being at the conference and for taking the time, the extra time, to be on this panel. I just wanted to start by asking you how you got to where you are. So all of you are talking today about leadership, and for some of you that may have been something that you intended all along in your career, saying, I'm going to focus on leadership at some point, whether starting as a leader or studying leadership. And for others, it may have been actually a bit of a surprise when you look back to your life. So very curious to hear how you got to where you are right now. Lama, would you like to start?
So I'm in academia, and it's a challenge to be in academia, and because you go through difficult steps, whether we're talking about promotion or tenure, and it's really difficult with kids and with and being in the Middle East, where we face a lot of exclusionary structural barriers that prevent women from contributing to the economy, and where the economic participation of women in the workforce is extremely low. It's the lowest in the entire world. So I found myself in a society where women have long been discriminated against, and I felt that whenever given the opportunity, I felt the need to make an impact, the need to drive a change from where I am, the need to change lives.
Thanks, Lama. Over to you, Ruth.
Well, my story is a little bit different. I had my career in medicine before I moved into investing and philanthropy, and there were a lot more women in the space. So in the obstetrics and gynecology field, many of my peers were women. And I think that what led me on a leadership path was when I was first given the opportunity to be chair of my department. And I'd never really considered doing anything like it before. And frankly, I went home and talked to my mom about it, who was a very successful consultant. And I said, I really like what I'm doing every day. Who needs it? It's just a headache to take on a leadership role. And she yelled at me. She said, don't ever say no when somebody's offering you an opportunity to have a more interesting professional life and to help others and just be supportive of others. And so from then on, I just kept saying yes. And here I am.
And what about you, Melinda?
I am still very early in my managerial journey. I wasn't planning on it. I was more interested in the technical challenges that came with the space. But when the opportunity presented itself, I thought about it, and it seemed to be a bad decision to say no. Similar to what Ruth said, I did think about, okay, is this an opportunity I should be pursuing? But then I am a kind of a person who debates her choices a lot, and even now I do. But one thing I can say for sure is when given this opportunity, I am learning how to be a better manager every day and how to be a better data scientist or machine learning engineer as well every day. So that's been my journey so far.
One of the things you often hear from people in the field is that becoming a leader in data science is particularly challenging compared to other fields because of the really high turnover that people see in teams. Folks very, very quickly moving from one job to another. And the other thing is that the field itself develops extremely fast. So as a leader, it's hard to stay on top. Melinda, you talked about challenges associated with the topic of anti-abuse, but these more general challenges that other people often mention, did you experience those as well when you stepped up to be a team lead?
I'd say my team is in a unique position where the turnover has been less than what you see outside. That said, I do see the challenges of stepping up to be a leader, and I think acting like an owner is what I would say helps with getting to a leadership position. That, apart from just doing the tasks assigned to you really well and being technically sound, it's just executing with a sense of ownership and just acting like an owner for the team, identifying how the team can execute better, and not just stopping with identifying the problems, but coming up with solutions, building good work relationships. All of this sounds like perhaps obvious, but I'd say, to me, acting like an owner is the best way to step up to be a leader, and do not be worried about stepping on somebody's toes. That's a mistake that I keep making. But I would like to remind myself that do not worry about it. It's just making somebody's job easier. But these kind of traits, I think, help with stepping up to being a leader, regardless of the high turnover.
Ruth, you've been through many stages of leadership in your career. Looking back on your career, what were the hardest transitions for you, and why?
It's a great question, and one of the things that we uncovered in our research for the book, The XX Edge, is that women actually excel in leadership and in decision making, not in spite of their lived experiences, but because of their lived experiences. And so in my career, both in medicine and being an executive at Kaiser Permanente, and now in my role at Tara Health Foundation, I think when I started my career, which was quite a while ago, the presumption was that you're supposed to leave your personal life and the problems that you're dealing with at home or in society, at home, and you don't bring them into the office, and you try and conform to the standards that in general men have established, the norms. And actually what I think is really clear is that when we do bring our personal lives and our lived experiences to bear in our decision making in whatever field we're in, that there's better solutions, that you can't ignore our lived experiences and how relevant they are to the problems or the data that you're working with. And so whenever capacity in my career, I think I've learned that actually, especially if you're trying to develop a more inclusive team and mentoring, that you can't ignore what's going on in the rest of your lives, that it's actually quite relevant.
What about you, Lama?
Well, I would like to follow up actually on your question, Margot, to Melinda. What is your advice to those women who aspire, young women who aspire to be leaders? In the MENA region, in my talk, I discussed the birthing pipeline, which is the disparity between the high graduation rates for women in STEM fields in the MENA region. Women graduate at more than 50%. The highest graduation rate in STEM fields globally. However, when it comes to their actual participation in the workforce in those STEM fields, it is about 10%. It's the lowest globally. So this disparity that I explain I explain in my talk is referred to as the bursting pipeline. The main issue with women joining stepping up as leaders in STEM field is the company's culture. So my advice to those young women is to carefully examine the company's culture before deciding to join to have a certain career at a certain company and step up the career ladder. It's important to work in organizations that are committed to diversity, equity, and inclusion. It's important to have this institutional commitment to support women so that they can grow, they can succeed. It's important also to network with other women, to have a mentor throughout their career, someone that they can refer to for help when making important decisions. And I want to tell those young women who aspire to be in a leading position, do not be afraid to take on a leadership or a development opportunity, no matter how difficult or how daunting this may look.
Great, thanks, Lama. So one of the things that I found so interesting in both Ruth's talk and your talk, Lama, was that you've been studying women leadership from a quantitative point of view also. So in other words, you're putting data into this discussion. And both of you point out the ability of women to really make significant differences. Have you found that putting some numbers behind this and really showing the data and showing the evidence is starting to make a difference in the perception of women as leaders, or do we still have a long way to go?
We still have a really long way to go. The data is overwhelmingly supportive that women in particular and diversity in general powers outsized performance. But there's a bias in the world that still holds women back. And I think, it's interesting in medicine, once there was good evidence, good science, we know that it takes on average 17 years before practice actually changes. And we think that's probably not unrealistic now that we have such good evidence around performance for diverse teams and women in particular, that it's going to take a while to break down those norms and to overcome bias.
Lama, what has it been like for you publishing your research on the glass cliff and other phenomena in the Middle East? Has it changed perception of women as leaders? Is it helping move the needle? More women can be accepted and also sought out to be leaders?
I agree with Ruth that we still have a long way to go. It's true that research studies have shown that including more women in leadership positions can enhance organization performance, can enhance profitability and reduce fraud and corruption. However, in the MENA region, the women's workforce participation is rising at a very, very slow rate. By 1% increase over the last 20 years. And this is according to World Bank. So we still have a lot to do. More efforts are needed to improve female representation in the workforce and in leadership positions. More efforts are needed by the private sector to commit to creating, implementing inclusive policies to hire and retain and develop and promote women. Government gender machineries can do a lot as well in the forms of ministries and council and committees. I mean, they're doing some work, but enforcement of legal frameworks to promote, to support and promote women in the workplace would help as well. Initiatives like Wits. So more and more, I believe more women should step in and lead initiatives and raise awareness about the importance of diversity and inclusion, supporting women for a more sustainable economic growth.
Let's talk a little bit about women stepping in and the barriers that they may be facing. And so in this discussion, already several hints and tips and pieces of advice have come up for women considering leadership positions. But I'd like to just pay a little bit more attention to it. So I'd love to start with Melinda. You have most recently taken that step. And when you think back 6, 7, 8 years ago, maybe when you were still a student, what sort of advice would you have liked to hear that would have helped you prepare better?
I think I heard the advice. I just didn't take it. That's what I'd put it as. But feel free to take risks. And that is an advice I believe I got from you, Margot. Like, take risks. There's not much to lose, really. And when it comes to research ideas, you don't know, the research idea might not pan out, but why don't you try it? So I'd say, yeah, try it. And same thing with leadership opportunities. Yeah, if something presents, you see something, why not try it? And yeah, and you see somebody, you admire them, why not reach out to them and say, hey, can I have a chat with you? I would like to learn a bit more about what you do. They might respond, they might not respond. What do you have to lose? So yeah, that's been my perspective. And thanks for the advice, Margot. It takes a while for things to seep into my brain, I presume. But no, that was an advice I did get, and I give it to people again.
I really like, Melinda, what you said about taking risks. And I think that we know that women tend to be more cautious, especially with promotions or volunteering for some new project. And we know that in general, this obviously everyone's an individual, but in general, men tend to be more willing to step up to something that they may not be quite qualified for, and they assume that they'll learn on the job. Whereas women are more cautious and they'll tend to wait until they are 95% sure that they can handle. And I think we know that we definitely know that women can do the jobs and need to take those risks and need to be putting themselves out there. And I also really love what you said about reaching out to people that you admire and cold calling them. And if they don't answer, so what? You haven't lost anything. But it's really flattering. And I where I am in my career, I get tapped by people, whether it's on LinkedIn or 3 degrees of separation, somebody will email me. And it's flattering, and it's nice to have people who acknowledge the work you've done and want your advice. And so chances are, if you reach out to somebody whose work you admire and you think they could really be helpful to you, they're probably going to say yes, and they're probably going to give you some time. And hold on to those relationships and come back to them. Maybe right now some advice is kind of relevant and you're not really sure how helpful it is, but 5 years from now, they'll still be there and they may very well be more relevant in how they can help you.
I would like to add to Ruth and Melinda. Yes, do not be afraid to take risks, to take on leadership opportunities. Do not be afraid to make mistakes. You will learn from them. And this is how we learn. And talk to previous leaders about their experiences, learn from them. There's nothing wrong to reach out to them and get advice from them. Also, it's important to find a mentor that will help you navigate difficult times, difficult decisions, making tough decisions. This would help as well.
Right. So one of the advice that I hear in between the lines here for those of us who are a little bit further along the leadership ladder is to take the time to help people and to become these mentors that everyone so would like to have. So I hope that we'll take that to heart, everyone. So thanks very much for spending a little bit more time with us and talking about your own experiences and your work. It's been a pleasure. Lama, Ruth, and Melinda from the East Coast, the West Coast, and Lebanon. Thanks very much for joining us. It's been so wonderful to have you all join us at this Wits Worldwide Global Conference. We are now turning to Brenda Darden-Wilkerson to give her inspirational closing address. Brenda is a fantastic advocate for access, opportunity, and social justice for historically excluded communities in technology. She currently serves as the president and CEO of our large sister organization and global nonprofit, AnitaB.org. In her talk, Brenda addresses the ongoing struggle for women in technical fields, including data science, and emphasizes the importance of recognizing our collective power to drive change.
Well, hello, everyone. It's truly a pleasure to be here with you today. And I'd like to start by thanking the conference organizers for this amazing opportunity to speak to women around the world. Women who are passionately dedicated to the field of data science, women who I know can help us bring about the much needed changes to data science, to tech, and to society. The importance of human involvement in the creation of tech cannot be overstated, especially now in recent years of rapid advancements in innovative technology. Despite achieving remarkable advancements in various areas such as self-driving vehicles, space-based internet, and gene modification, it baffles me that we continue to struggle with achieving equality and representation for women. Don't you find it interesting that women were the earliest forms of computers, which led people to landing on the moon in 1969? But here we are in 2023, still having discussions about why we need to have more women in data science. It's a bit frustrating, and yet it's even more urgent. Today, as we enter the age of artificial intelligence that we currently see today, we must recognize that as a tool, it has the potential to both shape our society in fascinating ways, as well as exacerbate existing inequalities, if not shepherded by a diverse group of individuals. Like many other technical fields, data science, the driving force behind that AI, still suffers not only from the significant lack of representation of women in the field, but also the lack of diversity in critical data points collected. Now, this can have real-world implications that can impact everything from hiring to healthcare. Let me give you some examples. In 2014, Amazon introduced an automated recruitment tool that would allow them to automate how they source top talent. But by 2015, it was uncovered that the system was not operating in a gender-neutral way. In effect, Amazon's system taught itself that male candidates were preferable. It penalized resumes that included the word women and downgraded candidates of 2 all-women's colleges. Despite best efforts to rectify this, Amazon's computer models had trained themselves to vet applicants by observing patterns in the resumes that had been accepted by the company over a 10-year period. Most came from men, a reflection of the male dominance in the tech industry, and therefore the tool learned how to become biased. Now, this tool was ultimately abandoned in 2017, but that's not too long ago. Here's another example. A 2020 study published in the Proceedings of the National Academy of Sciences found that because men's X-rays were predominantly used to train the CAD systems, the accuracy of women's diagnoses was dramatically lowered. Considering that heart disease is a leading cause of death in women, and that X-rays are used as an early detection tool to diagnose heart disease, that means the lives of our grandmothers, mothers, our sisters, our aunts, our daughters, even ourselves are literally on the line due to the lack of diverse data. So now that I've shared those examples, specifically around AI, how can we do the work to make sure that this tool doesn't exclude? The answer that I found through years of working at this is collective action. Simply put, it's you plus me, which equals we. Despite what we've been told, our voices and our presence are powerful. Many times we think that if we're alone, we can be invisible and dismissed. But if we're a vocal and visible collective together, the greater chance that we can't be ignored. In acknowledging the collective power of our voices and our collective presence, we can bring about change and ensure that the technology built to serve humanity actually does that. To illustrate the impact of collective action, let me tell you a story of the Family Medical Leave Act, or better known as FMLA. This act was created as a way to extend job protections post-pregnancy, following the Pregnancy Discrimination Act of 1978. This act made it illegal for any employer to discriminate based on pregnancy, childbirth, pregnancy-related conditions, or the possibility of future pregnancy. Devised by the Women's Legal Defense Fund in 1984, the draft of legislation that would later become FMLA faced numerous obstacles and was actually vetoed twice by President George H.W. Bush after passing Congress in 1991 and 2. It wasn't until 1993, under President Clinton, that FMLA became official. These benefits that we now have, that everyone has, are the result of the undeterred and collective leadership of the Women's Defense Fund, which later became the National Partnership for Women and Families. And it was under the guidance of some extraordinary women, Judith L. Lichtman, Donna Lindhoff, and Deborah L. Ness. Now, speaking of benefits, I've been emphasizing the importance of collective voice and presence. I think it's important to recognize that change starts with us. We must be the change we want to see. I'm proud to say that I'm not just talking the talk, but I'm walking the walk by taking that to heart within my own organization. Prior to designating benefits available to our team this year, our exec team collectively led an activity that gave staff an opportunity to share what's important to them from a benefits perspective. It was honestly one of the best activities we've ever done, not only allowing our leaders in our organization to hear straight from our staff, but also allowing staff to feel seen, heard, and valued. It also showed staff the difficult decisions that leaders must make when it comes to designating benefits or for creating environments of inclusivity. But as a way to show that we indeed did hear them and see them, at the start of 2023, AnitaB.org announced the official adoption of a new parental leave, fertility, and adoption support benefit for both full and part-time staff. Parental leave is now available for all parents, not just birth parents. Now, I purposely highlight the origin story behind FMLA and what we're doing at AnitaB.org to serve as a reminder that we can face challenges head-on and through collective action of our voice and our presence. We can create a movement for change. Now, I know I don't have to tell you this, but the beauty of being technologists is that we solve problems. We ask hard questions and we find solutions. Each of us here would not be here if we didn't. Each time tech has advanced, there have been those that stand in the gaps to ensure that those of us who often are an afterthought are heard and seen. Has this always been easy? No. Does it require that we roll up our sleeves and push back? Yes. So whether it's AI today or some innovative thing that we haven't even discovered tomorrow, rest assured that we have the power to create change, especially when we come together as a collective. Now I'll leave you with this. There's an African proverb which goes, if you want to go fast, go alone. If you want to go far, go together. It's time that we go together. Let's go together. You plus me equals we. Thank you.
Thank you so much, Brenda, for closing our conference in such a powerful way. And thanks to all our speakers today for sharing their insights and passions. And of course, to all of you for joining us. We do have a collective power to drive change. At Wits, we are passionately pursuing our mission to create a supportive and inspiring community for all, and to provide programming for everyone, everywhere, and at no cost. And of course, to elevate and empower women in the field across the globe. We want to change the field and grow the representation of women and amplify all our voices. Work with us and work with our sister organizations such as AnitaB, Women in Data USA, Women in Analytics, Women in Big Data, Black Women in AI, DARE, and many others, so that we can drive change collectively. Join us. We welcome everyone. Become a Wits ambassador in your community. Organize Wits events, participate in our Datathon, volunteer to give workshops and share your skills, mentor and guide others, elevate your women colleagues, and acknowledge and celebrate contributions they make whenever and wherever you can. Become a sponsor. become a donor and help further our mission. You can reach out to us through our website and on our LinkedIn group. Of course, join it. And of course, also by emailing us at contact@witsworldwide.org. contact@witsworldwide.org. We look forward to hearing from you. Thanks again so much for joining us today. We hope you really enjoyed the talks and panels and will share the videos in your communities. See you at the next Wits event. Thank you. Gracias. Shukran. Shishi. Reuze bedankt.